Hello, and welcome to this quiet space. Perhaps you're lying in bed right now, thoughts circling, or maybe you've found yourself here in search of something softer than answers, a place to let your mind drift while still feeling tethered to something real, something profound. Either way, you're welcome here. Tonight we begin with a question that sounds almost absurd at first, the kind of question that makes you smile and shake your head. But here's the strange thing. Some of the most accomplished physicists alive take it seriously, puzzle over it, build entire careers around it. The question is simple enough to state: what if time isn't real? Not that it's an illusion, exactly. Not that your experience of moments passing, one after another, is somehow false or mistaken. But what if time, as we've always understood it, as this fundamental river carrying us from past to future, what if that's not quite what reality is doing? What if now and then and soon are patterns we observe, structures that emerge from something deeper, something that doesn't flow at all? Quantum experiments, real experiments performed in laboratories around the world, suggest that reality might exist in timeless configurations, events and states simply arranged in relationship to one another, with the sense of now emerging as a pattern rather than an absolute. It's a little like asking whether up exists in empty space. The question itself makes you reconsider what you thought was obvious. Let's begin with something you might already know, though perhaps you've never quite felt its strangeness. Einstein showed us, proved mathematically, confirmed through observation, that time doesn't tick at the same rate everywhere. Near massive objects, in strong gravitational fields, time slows down, not perceptibly to those experiencing it, but measurably, definitively, when compared to clocks ticking elsewhere. Astronauts aboard the International Space Station age slightly slower than people on Earth's surface. Not by much, we're talking microseconds over months, but it's real. GPS satellites orbiting overhead experience time faster than we do down here, and their programming must account for this, or they'd quickly give us wrong positions. These aren't illusions or approximations. These are revelations about time's nature. Think about what this means. Two clocks, both perfect, both keeping time flawlessly, can disagree about how much time has passed, not because one is broken but because time itself behaves differently depending on where you are, how fast you're moving, how close you are to mass. Time bends, time stretches, time behaves less like an absolute backdrop against which events occur, and more like space itself, flexible, relative, malleable. Einstein called this space-time, treating time as a fourth dimension, alongside the three dimensions of space. In his equations, when becomes just another coordinate, like longitude or altitude, you exist not just at a location in space, but at a location in space-time, a four-dimensional address marking where and when you are. But if time is a dimension like space, does it flow? Does north flow? Does up flow? Perhaps when is just another aspect of where. Perhaps the question, what time is it, is really asking, where am I in the fourth dimension? The universe might not carry us through time. We might simply exist at different temporal coordinates, experiencing our position in time the way we experience our position in space, as location, not motion. This isn't speculation. This is what relativity tells us, and yet it contradicts almost everything about how time feels to us. When you remember yesterday, it feels gone. When you anticipate tomorrow, it feels not yet existing. The present moment feels privileged, real in a way past and future aren't, but Einstein's equations don't make that distinction. In the mathematics, all moments exist equally, so we're left with this tension: physics that treats time as space, and experience that treats time as flow. Both seem true, both seem undeniable, and somewhere in that contradiction lies something profound about what reality actually is. Now we go deeper, into territory that becomes genuinely strange. In the 1960s, physicists John Wheeler and Bryce DeWitt tried to write an equation that would describe the entire universe quantum mechanically. They succeeded, in a way. They produced an equation now called the Wheeler-DeWitt equation that does describe quantum gravity, that does account for the universe as a whole, but their equation has a peculiar feature. It contains no time variable. None. The equation describes the universe as a static, timeless object. Everything that ever happens, happened, or will happen exists simultaneously in this mathematical description. Past and future aren't separate eras, their coordinates in a frozen four-dimensional block where all moments coexist. Imagine a film reel. Every frame exists simultaneously, arranged in order on the strip of celluloid. When you watch the film, it moves. You perceive motion, story, change. But the film itself isn't moving. The frames simply exist, laid out in sequence, and consciousness reads them one after another, creating the illusion of time passing. Wheeler-DeWitt suggests the universe might be like that reel, static in its total structure, with time emerging only as we read our way through it. This is called the block universe or eternalism, the idea that past, present, and future all exist with equal reality. Your birth exists, your death exists, this moment right now exists, and they're all equally real, all equally now in some fundamental sense, even though your consciousness only experiences one moment at a time, like a flashlight beam illuminating one small patch of a vast, unchanging landscape. The mathematics work beautifully. Solutions to Wheeler-DeWitt describe entire cosmic histories, every event, every moment, every configuration, all at once, not evolving, but simply present. Yet this portrait contradicts our deepest intuition about reality, that the past is gone, the future hasn't happened yet, and only now is real. Physics and perception diverge here, sharply and completely. One says time doesn't exist fundamentally. The other insists time is the most obvious feature of existence. Both seem true from their respective positions, and reconciling them, understanding what the universe actually is, remains one of physics's deepest puzzles. And perhaps it invites us to wonder which reflects truth, the equations, our experience, or somehow impossibly both. But there's another way to think about time, one that might reconcile these perspectives. Carlo Rovelli, an Italian physicist whose work on quantum gravity has reshaped modern physics, proposes something subtle and beautiful. What if time doesn't emerge from duration passing, from moments flowing one after another, but from entropy, from disorder increasing? Think about why we know which direction is forward in time. It's not because clocks tick. We could imagine clocks running backward. It's because certain things happen in only one direction. Eggs break but don't unbreak. Coffee and milk mix but don't spontaneously separate. Heat flows from hot to cold, never the reverse. These processes all share something. They move from organized states to disorganized ones, from low entropy to high entropy. Entropy is a measure of disorder, of how many ways the constituents of a system can be arranged. A broken egg can be arranged more ways than an intact one. The shell fragments scattered differently, the yolk spread variously, so it has higher entropy, and the universe, for reasons still debated, always moves toward higher entropy configurations. That's the second law of thermodynamics, perhaps the most fundamental law in physics. Rovelli suggests that events organize themselves not through chronology, not through a flowing river of time carrying them from past to future, but through correlation and entropy increase. Event A happened before event B, not because time flowed between them, but because A is in a lower entropy state, correlated with B's higher entropy state. The universe might be a vast tapestry of relationships, where before and after describe thermodynamic ordering rather than temporal flow. In this view, time isn't fundamental. It's secondary, derivative, emergent, like temperature emerging from atomic motion or wetness emerging from how H2O molecules behave together. The deep reality might be timeless, with time appearing only where entropy gradients exist, only where order gives way to disorder, where there's no entropy change. Perhaps there's no time either, just static configurations, related to one another but not flowing. This is organizing without duration. This is reality structured not by a clock but by the fundamental tendency toward disorder, and it suggests that time, this most basic feature of our experience, might be something the universe is doing locally, not something the universe is built from, like waves on the ocean's surface, real, observable, impactful, but not themselves what water fundamentally is. So if time might not be fundamental, if it might be emergent or even illusory in some deep sense, let's begin by examining what we actually experience. What do you mean when you think now? It turns out the now you experience isn't instantaneous, it has duration. Neuroscience reveals that the present moment, the span of time that feels simultaneous to you, lasts roughly 3 seconds, This is your brain's integration window, the interval across which sensory information gets bundled together into a coherent experience of right now. Why 3 seconds? Partly because sensory signals travel at different speeds. Touch information from your hand reaches your brain faster than visual information from your eyes, which reaches faster than sound from your ears. Yet you experience the touch and sight and sound as simultaneous, watching someone clap and hearing the clap at the same moment. Your brain backtracks, adjusts, creates coherence across signals that arrived at different times. This isn't passive reception, this is active construction. Your consciousness doesn't observe time, it creates temporal structure from timeless information. The sensory data simply is neural patterns, chemical signals, electrical impulses. Your brain organizes these patterns into now, then, next, imposing sequence and flow on what might be a collection of static correlations. Consider what happens when you listen to music. Individual notes arrive sequentially, but you perceive melody, a structure that requires holding earlier notes in awareness while processing current ones. The present moment must encompass enough time to contain relationships between notes, not just individual sounds. 3 seconds allows your consciousness to grasp phrases, patterns, meaning, to experience temporal flow rather than disconnected instants. Studies of time perception show this window expanding or contracting depending on attention and emotional state. When you're bored, time dilates. When you're engaged, it compresses. But it's always an integration window, always a constructed present rather than a mathematical instant. What you call now is already a small story your brain is telling about what's happening, not a snapshot of objective simultaneity. And here's where it gets interesting. If the present moment is a construction, assembled from information that doesn't itself come with timestamps, what does that suggest about time's fundamental nature? Perhaps consciousness doesn't observe time passing through an objective present moment. Perhaps consciousness is what present moments are, the way timeless information organizes itself into experienced flow within systems, complex enough to integrate and correlate multiple signals. This doesn't mean time is fake. Emergence is real. Temperature is real, even though it emerges from atomic motion. Wetness is real, even though individual H2O molecules aren't wet. If time emerges from how consciousness structures information, that makes time subjective in origin but objective in experience. Real for us, perhaps not fundamental to the universe, but no less actual for that. The architecture of now then might be precisely that, architecture. A structure built by nervous systems from materials that don't themselves flow. You exist in a 3-second bubble of constructed present, reading timeless patterns as if they were a river carrying you forward. And perhaps that's not what time is, but it is what time feels like, which might be the only kind of time that matters for beings like us. Now let's descend into the quantum realm, where time becomes even stranger. At the scale of particles, electrons, photons, atoms, entities don't behave like little billiard balls moving through space and time. They behave like possibilities distributed across many states simultaneously. An electron doesn't have a definite position until measured. Before measurement, it exists in superposition, multiple locations at once, not because it's moving quickly between them, but because it genuinely is spread across them simultaneously. This isn't ignorance about where it really is. The mathematics of quantum mechanics, confirmed by countless experiments, tells us the electron doesn't have a single location before measurement. It has a cloud of potential locations, all equally real, until observation collapses them into one. This suggests something profound about time. If particles exist in multiple states simultaneously, are they moving through time or distributed across possibilities? The standard interpretation treats superposition as existing at a moment in time. The electron is in many places now, but physicists exploring timeless quantum mechanics suggest superposition might be more fundamental than that. Perhaps particles don't move through time but simply exist in relationships with other particles. Relationships we interpret temporarily because of how our consciousness processes information. Consider quantum entanglement, where two particles become correlated, such that measuring one instantly determines the state of the other, regardless of distance. Photons entangled on Earth show instantaneous correlation when one is measured here and another on the Moon. This doesn't violate relativity, no information travels faster than light, but it does suggest space-time might be emergent from deeper networks of quantum relationships. If space-time emerges from quantum entanglement networks, then space and time aren't fundamental. They're patterns in how quantum states relate to each other. Distance becomes a measure of how many entangled links separate two particles. Time becomes a measure of how correlation patterns change. But at the deepest level, there might be no space, no time, just quantum states in mathematical relationship, with space-time emerging wherever those relationships become complex and stable enough. This is called emergent space-time, and it's not fringe speculation. It comes from serious attempts to reconcile quantum mechanics with general relativity, to understand what happens at the Planck scale, where both theories must apply. Some of physics' most brilliant minds, including string theorists and loop quantum gravity researchers, converge on this conclusion: space-time probably isn't fundamental. Reality's foundation at the quantum level may contain no clocks at all, no ticking, no flow, no sequence of moments, just relationships between quantum states, correlations between particles, information encoded in entanglement patterns. Time emerges from these relationships, the way temperature emerges from atomic motion, as a useful description of complex behavior, not as a fundamental entity. And yet here we are, experiencing time's flow deeply and undeniably. The quantum timelessness doesn't erase your experience of duration. It suggests instead that what feels most basic to us, the passage of time, the distinction between now and then, might be emergent properties of how quantum relationships stabilize into the classical world we inhabit. We live in the emergent layer, where time has crystallized from timeless correlations, and our experience is no less real for that. The mystery isn't resolved, it's deepened. Reality might be timeless at its foundation, but somehow that timelessness gives rise to time in our layer of existence. Like how static film frames give rise to moving pictures, or how timeless equations give rise to dynamic predictions. Both the timelessness and the time are real, just at different levels of description, and we're left wondering which level reveals what the universe truly is. Let's now confront directly what Einstein's relativity implies about time's structure. The mathematics are clear, and the experimental confirmation overwhelming. Space-time is a four-dimensional manifold where all moments coexist with equal ontological status. This is the block universe, eternalism, and it's not metaphysical speculation but the straightforward reading of our most successful physical theory. Here's what it means. Your birth exists, not existed in the past tense, but exists right now, somewhere in space-time. Your death exists too, already laid out in the four-dimensional structure, even though your consciousness hasn't yet experienced that moment. Every instant of your life, every choice, every breath, exists simultaneously in the space-time block. Past and future are just directions in the fourth dimension, like north and south in space. This feels wrong. When you remember your childhood, it feels gone. Accessible only through memory, no longer present in reality. When you anticipate tomorrow, it feels not yet existing, still indeterminate. The present moment feels privileged, feels more real than other moments, but according to relativity, this feeling is an artifact of consciousness, not a feature of reality. Consider what relativity says about simultaneity. Two events can be simultaneous for one observer, but sequential for another observer moving differently. There's no universal now stretching across space. If you're on Earth and someone's on a spacecraft traveling near light speed, you'll disagree about which distant events are happening right now. Both of you are correct within your reference frames. There's no privileged perspective declaring which moment is the present. This means the present moment, the distinction between now and then, isn't built into space-time's geometry. It's observer-dependent, relative, like velocity or direction, and if there's no universal present, then all moments must have equal reality. Past, present, and future are equally existent, just located at different coordinates in the four-dimensional space-time manifold. Time becomes geography in this picture. The distance between your birth and death is a separation in the time dimension. Like the distance between New York and Paris is a separation in space. You can't travel backward in time any more than you can travel to yesterday's location in space, because yesterday isn't a different place, it's a different when, and moving through space doesn't change when you are, but in principle, the temporal dimension is traversable, just geometrically different from spatial dimensions. We might be four-dimensional beings perceiving ourselves three-dimensionally, moment by moment, Like a 2D creature living on the surface of a sphere, unable to perceive the third dimension curving their world, we might inhabit 4 dimensions but only experience 3 at any instant. Our consciousness slides through the 4th dimension, illuminating each moment sequentially, creating the illusion of flow while the entire structure remains static. This is deeply counterintuitive. It suggests everything that will happen to you has already happened. In a sense, it exists in the future region of your space-time trajectory. Your choices haven't yet been experienced by your current consciousness state, but they exist as facts about space-time's geometry. Free will becomes puzzling in this framework, though perhaps not impossible. We'll explore that later. For now, sit with this idea. You are not a 3-dimensional being moving through time. You are a 4-dimensional structure extended through space-time, a long, thin world line connecting your birth to your death, curved and complex, interacting with other world lines, existing in its entirety all at once. Your consciousness experiences this structure sequentially, moment by moment, but the structure itself doesn't flow. It simply is, laid out in 4 dimensions, permanent and complete. This is what relativity tells us. Not a theory, not a guess, but the logical consequence of equations that predict gravitational waves, black holes, cosmic expansion, all confirmed by observation. The block universe is built into our best description of reality, and yet it contradicts our experience so completely that physicists still debate what it means, whether it's true, how to reconcile the math with the feeling of time passing. Both seem undeniably real. Both can't be fully true as we understand them, and somewhere in that paradox lies something we haven't yet grasped about what existence is. So if time might be emergent rather than fundamental, we need to understand what emergence means, because it's tempting to think emergent means not real, but that's not quite right. Emergence is one of the most important concepts in science, and understanding it helps clarify what we're actually saying about time. Consider wetness. You feel wetness when you touch water. It's a real property directly experienced, but individual H2O molecules aren't wet. Wetness emerges from how many molecules interact with your skin, how they flow and stick and evaporate. A single water molecule has no wetness. 10 molecules have no wetness. At some point, probably thousands or millions of molecules, the property of wetness emerges from their collective behavior. Is wetness an illusion because molecules aren't wet? Of course not. Wetness is real. It's just not fundamental. It's a higher-level property arising from lower-level physics. The molecules don't know they're creating wetness, but the wetness is genuine nevertheless. Emergence creates new properties that don't exist at lower levels, but are completely real at higher levels. Temperature works the same way. Temperature is average molecular kinetic energy, how fast atoms are vibrating or moving. An individual atom has no temperature. Temperature only exists for collections of many atoms, where averaging becomes meaningful. Yet temperature is absolutely real. You can measure it, feel it, predict it. It's emergent, yes, but that doesn't make it illusory. Perhaps time emerges from timeless quantum relationships. Similarly, the fundamental level, quantum fields, entangled states, wave functions, might contain no time, no flow, no sequence. But when quantum systems become sufficiently complex, when they decohere and entangle with environments, when they form records and correlations, time emerges as a property of these complex systems. The river of time might flow from a motionless source none of us can directly observe. This doesn't make your experience of duration fake. It makes time a real emergent phenomenon rather than a fundamental ingredient of reality. You experience time because you're a complex system embedded in an environment where entropy increases, where quantum states decohere, where information accumulates as memory. Time is how beings like us navigate and describe changes in quantum correlations. Carlo Rovelli's thermal time hypothesis exemplifies this. He proposes time emerges from the thermodynamic properties of quantum systems, from entropy gradients, from the statistical behavior of many particles. Where there's no entropy change, there's no time. Time is local, emerging wherever sufficient complexity allows thermodynamic gradients to form. Different regions might experience time differently or not at all. But, and this is crucial, emergence doesn't mean reduction. You can't fully describe or predict emergent properties just by understanding the lower level. Wetness has properties that aren't obvious from studying individual molecules. Temperature behaves according to thermodynamics, laws that don't appear in the equations governing individual atoms. Emergent properties are genuinely new, irreducible to their substrates, even though they depend on them. If time is emergent, then temporal laws, causation, entropy increase. The distinction between past and future might not reduce to timeless quantum mechanics. They might be genuinely new laws governing the emergent level, as real as thermodynamics is real despite emerging from statistical mechanics. This preserves time's reality while acknowledging it might not be fundamental. The word illusion implies something fake, misleading, deceptive. But emergence isn't deception, it's layered reality. Temperature is real, even though atoms don't have it. Wetness is real, even though molecules aren't wet. And time might be real, genuinely, undeniably real, even if the universe's deepest level contains no clocks, no flow, no duration. Emergence and reality aren't opposites. They're how complexity builds genuine new features from simpler foundations. So when we say time might be emergent, we're not saying time is fake. We're saying time is like wetness, a real property of sufficiently complex systems, arising from but not reducible to deeper timeless physics. The river flows, the source is still. Both descriptions are true at their respective levels, and understanding this lets us hold both the mathematical timelessness and experiential flow without contradiction, seeing them as different perspectives on layered reality. Now we encounter one of quantum mechanics' deepest puzzles, one that intimately connects to time's nature. It's called the measurement problem, and despite a century of brilliant work, physicists still don't agree on how to resolve it. But exploring it reveals something crucial about time, observation, and reality's structure. Here's the puzzle. Quantum systems exist in superposition until measured, multiple states simultaneously, not uncertain but genuinely plural. An electron is in many places at once. A photon travels multiple paths simultaneously. But when you measure the system, it collapses to a single definite state. The electron has one position. The photon took one path. The multiplicity vanishes, replaced by singularity. This collapse seems to require time. Before measurement, superposition. After measurement, definite state. The transition from before to after appears temporal. Something changes when observation occurs. And yet the Schrödinger equation, which governs quantum evolution, is perfectly time-symmetric. It works equally well forward and backward. The collapse isn't in the equation. It seems added by measurement itself. But what is measurement exactly? When does it happen? Does it require conscious observers, or do unconscious detectors count? Does the collapse occur when particles interact with measuring devices, or only when humans look at results? These questions have no agreed answers. Different interpretations of quantum mechanics resolve them differently, and all produce identical experimental predictions. We can't test between them. Some physicists, like Roger Penrose, propose that consciousness itself causes collapse. Observation literally creates definite states from quantum possibilities, and temporal order emerges from this process. Time becomes bound to awareness. No consciousness, no collapse, no temporal flow. This sounds mystical, but Penrose grounds it in serious proposals about quantum processes in neurons, about gravity's role in wave function reduction. Others suggest observation is just entanglement. When a quantum system interacts with an environment, even an unconscious detector, it becomes entangled, creating correlated records. This decoherence process makes superposition practically unobservable, creating the appearance of collapse without requiring it fundamentally. Time emerges from correlation accumulation, from information spreading through entanglement networks. In this view, consciousness doesn't create time, rather consciousness and time co-emerge from quantum information processing in nervous systems. Your brain is a fantastically complex quantum system constantly decohering, constantly entangling with its environment, constantly generating correlated records we call memories. Time might be what this process feels like from the inside, the experiential signature of information integration in self-referential quantum systems. But here's the strange part. If observation creates temporal order, or if time emerges from decoherence, then the equations underlying everything remain timeless. The Schrödinger equation, the Wheeler-DeWitt equation, the fundamental laws don't contain time as an ingredient. They describe relationships, correlations, quantum states, all without reference to when. Time appears only at the emergent level, only where observation or decoherence occurs. This suggests time might be local rather than global. It emerges where quantum systems are sufficiently complex and interactive, where they build records and maintain correlations. Perhaps time exists strongly inside your brain, moderately in your environment, weakly in distant galaxies, and not at all in isolated quantum systems. Time is a property of information processing regions, rather than a universal backdrop. The measurement problem thus casts a temporal shadow. It suggests that whatever time is, it's intimately connected to observation, to information, to the process by which definite states emerge from quantum possibilities. Whether consciousness causes this, or merely participates in it, remains unresolved. But the deep connection between observation and temporality hints that time's nature is inseparable from how reality becomes definite, how possibility crystallizes into actuality, and we're left with this. The most successful physical theory we have, quantum mechanics, works perfectly without time at the fundamental level. Time appears, if it appears, only in the measurement process, only where quantum systems interact with complex environments or conscious observers. This doesn't solve the measurement problem, it deepens it, but it suggests that understanding time requires understanding observation, and vice versa. They might be two aspects of the same fundamental mystery about how reality manifests. Let's now explore why time has a direction, why we remember the past but not the future, why causes precede effects, why eggs break but don't spontaneously reassemble. This directionality, called time's arrow, emerges from thermodynamics, from the tendency of closed systems to move toward disorder. It's one of the universe's most fundamental asymmetries, and understanding it illuminates what time might fundamentally be. Entropy measures disorder, the number of ways a system's components can be arranged. A shattered glass has high entropy, because the fragments can be arranged countless ways while still looking like a broken glass. An intact glass has low entropy, because only specific arrangements maintain its structure. The second law of thermodynamics states that isolated systems' entropy increases over time. Order gives way to disorder. Structure dissolves into randomness. This law defines time's arrow more reliably than any other physical principle. If you watch a video of a glass breaking, you immediately know which direction is forward in time. Glass shattering increases entropy. If the video shows fragments spontaneously assembling into an intact glass, you know it's running backward. Entropy increase reliably indicates time's forward direction. But here's what's strange. The fundamental equations of physics don't prefer one time direction over the other. Newton's laws work identically forward and backward. Quantum mechanics' Schrödinger equation is time symmetric. Even Einstein's relativity treats past and future equivalently. At the most basic level, physical laws don't distinguish between time running forward and backward. They permit both equally. So where does time's arrow come from? Not from fundamental physics. It must emerge from somewhere else, from boundary conditions, from cosmology, from the universe's specific history. And the most popular answer points to the Big Bang. The universe started in an extraordinarily low entropy state, highly ordered, compressed into an infinitesimally small region. That's a very rare, very special configuration. Since then, the universe has been expanding and entropy has been increasing. Stars form and burn out, scattering energy, galaxies evolve and collide. Black holes grow everywhere, in every direction. Entropy increases as the universe moves from its rare initial low entropy state toward more probable high entropy configurations. We're riding an entropy gradient that began 13.8 billion years ago and continues today. Time's arrow, then, might be cosmological. It points in the direction of increasing entropy, which points from the Big Bang toward whatever far future high entropy state awaits. If the universe had started in a high entropy state, in thermal equilibrium, everything evenly distributed, there would be no entropy gradient, no thermodynamic arrow, and possibly no time direction at all, just a static, featureless soup of particles in equilibrium. But why did the universe start in low entropy? We don't know. It's one of cosmology's deepest mysteries. Some propose eternal inflation, bubble universes constantly forming, with ours happening to start in low entropy. Others suggest cyclical cosmologies, where entropy resets at each cycle. Still others think the question is ill-posed, that the Big Bang's low entropy is a brute fact requiring no deeper explanation. Regardless, the arrow exists, and it might be what time is. Carlo Rovelli and others propose that time doesn't exist separately from thermodynamic processes, that time is just our name for entropy gradients, for the direction in which disorder increases. Where there's no entropy change, there's no time. Time is fundamentally thermodynamic, not geometric or chronological. This explains why we remember the past but not the future. Memory is a low entropy to high entropy process. Creating a memory increases your brain's entropy. Neurons reorganize, energy dissipates. You can create records of earlier lower entropy states, but not later higher entropy ones. Causation itself might be thermodynamic. Causes are lower entropy states correlated with higher entropy effects. So the arrow, this fundamental directionality, emerges from cosmology, from the universe starting wound up like a spring and slowly unwinding. At the deepest level, physics sees no arrow, but at our level, embedded in the entropy gradient between Big Bang and heat death, time has unmistakable direction. Past and future aren't symmetric. They can't be reversed. The arrow is real, even if the underlying laws don't prefer it. And this reveals something profound. Time might be inseparable from the universe's history, from its specific trajectory through configuration space. Not a universal backdrop, but a property of how our universe happened to evolve. Other universes, other histories, might have different arrows, weaker gradients, even no time at all. Time emerges with, and perhaps is, the thermodynamic story our universe is telling from beginning to end. Now we encounter one of the most beautiful and strange proposals in modern physics. Julian Barber's vision of a timeless universe called Platonia. Barber is a British physicist who has spent decades developing a theory where time doesn't exist, where change is illusion, where everything simply is in one eternal, unchanging mathematical structure. Platonia is the space of all possible configurations. Imagine every possible arrangement of every particle in the universe, every different way matter and energy could be distributed across space. Each configuration is a point in Platonia, a now that exists eternally. The entire space contains every possible moment, your birth, your death, dinosaurs roaming Earth, galaxies forming, stars exploding, every configuration that could exist. In Platonia, nothing moves or changes. All configurations exist simultaneously, arranged according to mathematical relationships between them. Time doesn't flow through Platonia. Consciousness reads it sequentially, experiencing configurations one after another, but the configurations themselves don't evolve. They're eternal, like pages in a book that exists completely, all at once. This sounds absurd until you consider the evidence. Remember that the Wheeler-DeWitt equation describes the universe timelessly. Remember that relativity treats all moments as equally real in space-time's block structure. Barber argues these aren't approximations or metaphors. They're literally true. The universe is timeless. Change is how conscious beings read a static landscape. Why do configurations seem ordered? Why does one follow another? Because Platonia has structure. Configurations aren't scattered randomly. They're arranged in clusters, connected by paths of similarity. Nearby configurations in Platonia are similar to each other, almost the same arrangement of particles, differing only slightly. Consciousness, Barber suggests, follows paths through these clusters, experiencing similar configurations sequentially, and interpreting that as continuous change. Think of a movie again. Individual frames exist separately, complete in themselves. They don't move, but they're arranged in order, each slightly different from neighbors, and when consciousness reads them sequentially, we perceive motion. Platonia is like an infinite movie where all frames exist eternally, and consciousness is the reading mechanism that creates the illusion of time passing. This explains why the universe seems governed by laws. Laws aren't rules that make things happen. They're descriptions of which configurations are close together in Platonia, which paths consciousness is likely to follow. Physical laws describe Platonia's geometry, the structure of the timeless configuration space, not actual temporal evolution. Barber's theory is controversial. Many physicists find it beautiful but incomplete. It struggles to explain why consciousness follows particular paths, why we experience time flowing smoothly rather than jumping randomly through configurations, but it takes seriously what quantum gravity and relativity tell us. Time might not be fundamental. It might be how consciousness navigates a timeless mathematical structure, and there's something deeply satisfying about Platonia. It suggests that every moment exists permanently, that nothing is truly lost, that your entire life is an eternal structure in configuration space. You're not a spark that flickers and dies, but a permanent feature of reality's mathematical architecture. Every joy, every sorrow, every breath exists forever in Platonia's timeless expanse. This doesn't make change illusory in the sense of being fake. You genuinely experience duration, causation, memory, but these might be how it feels to follow a path through Platonia, rather than evidence that time itself flows. Like how motion in a movie is real experientially, even though the frames are static, the experience is genuine, the interpretation is what changes. So here we are, perhaps existing in this vast space of possibilities, with consciousness reading our way through configurations that simply are, creating the sensation of time from timeless patterns. It's a vision of reality both beautiful and strange, both comforting and unsettling. Everything exists eternally, nothing flows, and yet we feel time passing, undeniably and continuously, moment after eternal moment. Building on Platonia, let's develop what we might call the page-turner theory, a way of understanding how static configurations create the experience of flow. If we're books rather than rivers, if all moments exist like pages arranged in order, how does consciousness turn the pages, and why does it feel like movement? Consider a novel sitting on your shelf. All pages exist simultaneously, complete and unchanging. The story doesn't unfold, it's fully present, beginning to end. Yet when you read it, you experience narrative flow. Characters develop, plots evolve, tension builds. The story happens for you, sequentially, even though it exists entirely at once on those static pages. The reading experience is real, the emotional impact is genuine. Your engagement with the story unfolds temporarily as you progress through pages, but the book itself doesn't flow. It sits motionless while your consciousness moves through it, creating temporal experience from spatial arrangement. The book is, the story happens, both are true from different perspectives. Now imagine you are that book. Your life's every moment is a page, already written, permanently present in the book of space-time. Your consciousness is the reading process, moving through pages, experiencing each sequentially, while all exist simultaneously. Memory creates continuity's illusion. Earlier pages inform understanding of current ones, creating a sense of connected narrative. Anticipation projects fictional futures, predictions about which pages might come next. Though those pages already exist, their content fixed. The present page isn't privileged except that it's the page consciousness currently illuminates. Like a flashlight beam sweeping across a landscape, the entire landscape exists, but only the illuminated portion is visible at any moment. Your experience of now is that illumination, moving through a four-dimensional space-time that exists completely, all at once. This explains why the present feels special. It's the moment you're experiencing, the page you're reading. Even though objectively all moments have equal ontological status, your consciousness can only illuminate one temporal location at a time, creating the sensation of a privileged present moving through time, when really it's consciousness moving through static space-time. But who or what is the page-turner? What moves consciousness through pages? This is where the theory becomes speculative, where physics gives way to philosophy. One possibility: there is no turner. Consciousness at each moment simply exists, complete with memories of earlier moments and experience of current ones. The movement of consciousness is itself illusion. All your consciousness states exist simultaneously, each experiencing its respective moment, with memory creating false continuity between them. Another possibility: consciousness moves, but timelessly. Like how a quantum particle takes all paths simultaneously, perhaps consciousness experiences all moments simultaneously, with the sequential feeling emerging from how memories link moments. You don't move through time, you exist across time, and memory creates the retrospective illusion of having moved. Or perhaps, and this is closest to Barber's view, Consciousness follows paths through Platonia based on configuration similarity. You experience smooth time flow because each moment connects naturally to nearby moments in configuration space. Consciousness doesn't jump randomly through all possible configurations but follows paths of minimal change, creating the experience of continuous duration. The page-turner theory doesn't solve the hard problem of consciousness, doesn't explain why subjective experience exists at all, but it suggests how temporal experience could emerge from timeless structure. The pages don't flow, the story exists complete, and yet reading it, experiencing it from within, necessarily involves sequence, duration, the feeling of moments passing one after another. This reframes questions about free will, identity, meaning. If all pages exist, are your choices predetermined? Perhaps, but you still experience choosing, still navigate the story subjectively, even if objectively it's fixed. If all moments exist equally, what preserves personal identity? Perhaps memory, the fact that later pages reference earlier ones, creating narrative continuity across the book. And meaning. Perhaps meaning deepens in this view. Every moment matters eternally, not just transiently. The joy you felt yesterday didn't vanish. It exists permanently on its page. The love you'll feel tomorrow exists already, waiting on a future page. Your entire life is a complete story, existing all at once, each moment as real and present as this one, all pages equally part of the eternal book of you. So the page-turner might be consciousness reading reality, creating temporal flow from static pages. Or it might be that there is no turner, just pages existing, each containing conscious experience of its moment, with memory linking them into false continuity. Either way, the book is, the story happens, and we're left wondering whether the reading or the writing is more fundamental to what we are. If time doesn't flow, if all moments coexist in the block universe or Platonia, we face a profound puzzle. What is causation? Our deepest intuition about causes and effects is that causes come before effects, that the match must precede the flame, that temporal sequence defines causation. But in timeless physics there is no before, so how can causation work? Let's start with the obvious. In our experience, causes reliably precede effects. You flip the light switch, then the light turns on, never the reverse. You strike the match, then fire appears. The causal direction seems inextricably bound to time's arrow. We can't imagine causation without temporal sequence, without prior causes producing subsequent effects. But consider Barber's Platonia or the block universe. All moments exist simultaneously. The match striking and the flame appearing are both present, eternal configurations. They don't occur in sequence, they simply are. 2 points in space-time or 2 configurations in Platonia, yet we observe reliable correlation. Wherever there's a struck match, there's nearby a flame. The configurations are adjacent, reliably associated. Perhaps causation isn't about temporal sequence, but about correlation patterns in configuration space. Certain configurations are reliably adjacent to others in Platonia's structure. Fire follows match not because time flows from one to the other, but because reality's mathematical structure links these configurations, positions them near each other in the space of possibilities. Think of it like geography. New York and Boston are reliably near each other, not because New York causes Boston or vice versa, but because they're both positioned close together in physical space. Similarly, struck match configurations and flame configurations are positioned close together in Platonia or nearby in spacetime's block structure. The correlation is structural, geometric, not temporal. We interpret this geometry temporally because of entropy. The match struck no flame state has lower entropy than the flame state. Following the entropy gradient from low to high creates temporal order, earlier and later, but fundamentally, it's just correlation. Reality's structure ensures these configurations are adjacent, and entropy determines which direction we call future. This is causation without sequence. Causation as geometric relationship rather than temporal evolution. The laws of physics describe which configurations are reliably near each other, how they're arranged in Platonia or connected in spacetime. We perceive this as causes producing effects because consciousness reads the structure sequentially, following entropy gradients. But does this preserve what we mean by causation? If the flame already exists, eternally present in spacetime just like the struck match, can we really say the match caused the flame? Or are they both just features of spacetime's geometry, correlated but not causally related? Some philosophers argue this eliminates genuine causation, reducing it to mere correlation. If everything exists timelessly, nothing makes anything happen, things just are, arranged in patterns. Others argue causation remains meaningful as structural relationship. The match and flame are linked by physical laws, by energy transfer, by chemical reactions. Even if those linkages exist timelessly rather than temporally, perhaps causation is best understood as constraint. In the space of all possible configurations, certain patterns are allowed and others forbidden by physical law. Strike a match and you constrain what happens next. Flame becomes vastly more probable than, say, a flower blooming. Causation describes how configurations constrain nearby configurations, how reality's structure limits possibilities. This makes causation geometric rather than temporal, mathematical rather than dynamic. Causes don't make effects happen through time. They're configurations that constrain adjacent configurations in timeless structure. We perceive this as temporal because we experience configurations sequentially, but the causation itself is a temporal relation, and yet our experience insists causes precede effects. You never see flames preceding struck matches, never see effects before causes. This asymmetry is real, even in block universe or Platonia. It comes from entropy. The thermodynamic arrow ensures correlations point one direction. Low entropy states struck match come before high entropy states flame, because that's the direction entropy increases. So causation without sequence is causation structured by entropy gradients within timeless configuration space. The geometry is atemporal, but the reading is temporal, directed by thermodynamics. Both descriptions are true: timeless correlation patterns and temporal cause-effect sequences. Different perspectives on the same fundamental structure, neither more real than the other. This doesn't make causation less real or less important. It reveals causation as deeper than we thought, not dependent on time's flow, but on reality's mathematical structure, on how configurations relate in timeless space. Fire follows match because that's how physical law structures configuration space, not because time carries one into the other. The flame was always there, eternally adjacent to the match in spacetime's block. We're just discovering it, moment by moment, following the only path entropy permits through timeless reality. Even if we accept that all moments exist equally in spacetime's block, even if we embrace Platonia's timeless vision, one question remains brutally difficult. Why do you experience this specific now? Why are you conscious of this particular moment and not some other? This is the hard problem of nowness, and it's as profound as the famous hard problem of consciousness itself. Physics offers no answer. The equations describing space-time, Einstein's field equations, the Wheeler-DeWitt equation, quantum gravity proposals, contain no variable for present. They describe all moments equally, with no marker indicating which one is now. Mathematically, every moment is just a coordinate in four-dimensional space-time. None is privileged, none is the present. Yet you undeniably experience a specific now. You're reading these words at a particular moment, not at all moments simultaneously. Your consciousness is localized to this temporal coordinate, this slice of space-time, this page in the book. Why? What picks out this moment from all others that exist equally? One possibility: consciousness itself creates the present. Perhaps the universe doesn't have a now until consciousness manifests it. Like how observation collapses quantum superposition, perhaps awareness selects which moment becomes experienced as present. The block universe exists timelessly, but consciousness illuminates moments sequentially, and that illumination is what makes them now. This sounds mystical, but it's taken seriously by some physicists exploring consciousness's role in quantum mechanics. If observation creates definite states from quantum possibilities, perhaps it also creates temporal flow from timeless structure. Consciousness might be the universe's way of locally manifesting present moments from the eternal block. But this raises new questions. Why does consciousness illuminate moments sequentially? Why do you experience them in order, following entropy's arrow, rather than randomly or simultaneously? Perhaps consciousness is constrained by physical law to follow paths through space-time, unable to jump freely between moments. Like how a train follows tracks, consciousness follows the rails of causation and entropy. through the space-time landscape. Another possibility: every moment contains its own consciousness, experiencing itself as present. There's a version of you at every point along your world line, each experiencing their moment as now. The you reading this now is one such version. Yesterday, you experienced yesterday as now. Tomorrow, you will experience tomorrow as now. Each moment self considers itself present, unaware of other moment selves. This is the multiple consciousness interpretation. Consciousness is distributed across time, not moving through it. There is no single enduring you experiencing a sequence of nows. There are countless momentary yous, each existing at their respective temporal coordinate, each feeling their moment as uniquely present. Personal identity becomes a pattern connecting these moment selves through memory and physical continuity. This view is profoundly strange. It suggests you, this current you, won't become tomorrow you. Tomorrow you already exists at tomorrow's temporal coordinate, experiencing that moment as now. Today you will always exist at today's coordinate, experiencing this moment eternally. You don't move through time, you're distributed across it. Yet another possibility, more mysterious still. Nowness isn't explicable by physics because it's fundamental. Perhaps consciousness and presentness are basic features of reality, as fundamental as space or matter. Physics describes structures, space-time, quantum fields, configuration spaces, but doesn't explain experience. The feeling of now might be what it's like to be a conscious structure embedded in space-time, inexplicable by physics because it's prior to physics. This doesn't mean physics is wrong. It means physics describes reality from the outside, mathematically, while consciousness experiences reality from inside, subjectively. Both are real, neither reduces to the other. The hard problem of nowness might be unsolvable by physics, because physics isn't the right tool for explaining subjective experience. Or perhaps, and this is closest to emergence theories, nowness is what quantum information integration feels like. Your brain processes information, integrates signals, builds models of reality. This processing happens physically, through neural networks, chemical synapses, electrical signals, but from inside, it feels like experiencing a present moment. Nowness is the qualitative character of information processing, the subjective signature of consciousness integrating sensory data. In this view, now isn't a feature of space-time but of consciousness. Different conscious systems might experience different nows, depending on how they process information. Your now spans about 3 seconds because that's your neural integration window. A fly's now might be much shorter, and AI's now might be different still. Nowness is relative to the observer, not absolute in space-time. But none of these answers fully satisfy. The hard problem of nowness remains hard. Why this moment and not another? Why do you experience sequential flow rather than all moments simultaneously or none at all? Physics describes the block universe beautifully, but says nothing about why you're experiencing this particular coordinate within it. Perhaps the question itself is confused. Perhaps asking why this moment now presupposes a perspective outside time, where now makes sense as selection from possibilities. But there is no outside time. You're embedded in it. You're made of it. The question might be like asking, why am I me and not someone else? A grammatically correct question with no coherent answer. Or perhaps the answer is simple but ungraspable. You experience this now because you are this now. Your consciousness state is defined by its temporal location. It couldn't experience a different moment because then it would be a different consciousness state. You at this moment experience this moment because that's what you are. A moment of experience, happening eternally at this coordinate in space-time's block. The mystery remains. The equations describe structure, but not experience. And we're left with this irreducible fact. You are here, now, reading this, experiencing this specific moment out of all moments that exist. Why? Perhaps there is no why. Perhaps no-ness is simply what being is, what existence feels like from inside. The universe doesn't need a reason to be. Perhaps consciousness doesn't need a reason to experience now. Both simply are, timelessly and eternally, forever present in their own eternal way. Your memories seem to prove the past exists. You remember your childhood, specific events, feelings, places. Those memories appear to be evidence that the past really happened, that time flows from then to now, carrying events forward. But memory is tricky. It might be evidence, or it might be a trap, misleading us about time's nature. Consider what memories actually are. Neural patterns, physical configurations in your brain right now. When you remember breakfast this morning, you're not accessing the breakfast itself. That's gone. If gone means anything, you're accessing neural states encoding breakfast-related information. Synapses strengthened during the experience. Neurotransmitter patterns established. Neural networks activated. These physical traces persist into the present moment. In block universe terms, memories are correlations between your now slice and your then slice. Your current brain state is correlated with your earlier brain state in a way that allows reconstruction of information from the earlier state. Like how a footprint in sand is correlated with the foot that made it, the footprint contains information about the foot's shape, even though the foot is no longer present. But the footprint doesn't prove the foot moved through time. It proves correlation between two states, foot in sand and sand alone. Similarly, memory doesn't prove the past was real and then became unreal. It proves correlation between current neural patterns and earlier ones. The earlier ones still exist in their temporal location, eternally present in the block universe. Memory is how later temporal slices reference earlier ones. This means memory isn't proof of temporal flow, it's proof of structure. Space-time has consistency. Earlier states constrain later states. Information propagates through the temporal dimension. You remember the past but not the future, because entropy increases toward the future. Memory requires low to high entropy processes. Recording information increases entropy. You can't remember what hasn't yet been recorded in higher entropy states. But here's where it gets strange. False memories feel identical to real memories. Neural patterns encoding fabricated events activate the same brain regions, generate the same subjective certainty as patterns encoding actual events. If memories are just neural states, and neural states can be created without corresponding past events, how do we know any memories are real? This leads to the Boltzmann brain problem. Ludwig Boltzmann proposed that in an infinite universe undergoing random quantum fluctuations, occasionally a brain would spontaneously assemble complete with false memories of an entire life. A Boltzmann brain that existed for only an instant, but contained neural patterns suggesting decades of experience. How do you know you're not a Boltzmann brain right now, with all your memories assembled randomly instant ago? Statistics saves us, probably. Boltzmann brains are rare, extraordinarily, incomprehensibly rare compared to brains produced by normal evolutionary processes. The probability that you're reading this as a product of 13.8 billion years of cosmic evolution vastly exceeds the probability that you're a random fluctuation. But the possibility isn't zero. It can't be ruled out by memory alone. In timeless physics, this becomes even stranger. If all moments exist equally, your current state, including all memories, simply is one configuration in Platonia, or one slice of spacetime. The memories don't point to a real past. They're features of this configuration. Whether other configurations corresponding to those memories also exist is a separate question. Your memories correlate with other configurations, but correlation isn't proof of prior existence. Yet, we trust memories. We have to. They're our only access to anything beyond immediate experience. Without memory, you'd be trapped in an eternal present, unable to learn, unable to function. Memory creates continuity, identity, narrative. Even if memories are just present neural states, they're necessary for being a person over time. Perhaps the truth is layered. Memories are evidence of consistency in space-time structure, of how moments relate to each other geometrically. They're not proof of temporal flow, but proof of temporal order, that configurations aren't random, that later states are correlated with earlier ones, according to physical law. This is real information about reality's structure, even if it doesn't prove time flows, and practically, it doesn't matter. Whether the past exists eternally in the block universe or existed temporarily and is now gone, your memories function identically. They guide action, inform decisions, construct identity. The philosophical question of whether remembered events still exist is separate from the practical question of whether memories are useful. They are, regardless of time's ultimate nature. But memory remains a trap in this sense. It creates powerful intuition that the past is gone, that it existed then but doesn't exist now. This intuition might be false. The past might be as real as the present, eternally existent at its temporal coordinate. Memory doesn't reveal time's flow, it reveals correlation across time. Both views fit the evidence equally well, but they're profoundly different pictures of reality. So your memories don't prove what you think they prove. They prove correlation, consistency, structure. They prove space-time has order, that moments relate according to law, but whether those moments flow or simply are, whether the past is gone or eternally present, whether time is real or emergent, memory alone can't answer. It's evidence and trap simultaneously, revealing truth about structure while potentially misleading about flow. And we navigate this ambiguity every moment, remembering our way through eternal configurations we might never escape. Even if the universe is timelessly frozen in four-dimensional structure, even if physics contains no fundamental clock, life ticks forward relentlessly. Your heart beats, your cells divide, your body ages. Biology seems to require time to prove time flows. But does it? Or do biological clocks reveal something else about time's nature? Consider circadian rhythms, your internal 24-hour cycle governing sleep, alertness, hormone release, body temperature. These rhythms persist even in constant darkness, even without external time cues. Your body maintains its own clock, independent of environment. This seems to demonstrate that time exists independently, that biological processes require genuine temporal flow. But look deeper at what circadian rhythms actually are. Molecular oscillators, proteins that accumulate and degrade in cyclical patterns. Certain genes are transcribed, producing proteins that eventually inhibit their own transcription, creating feedback loops with roughly 24-hour periods. It's chemistry, molecules interacting, concentrations rising and falling, systems cycling through states. These molecular cycles track thermodynamic processes. Protein synthesis increases entropy, energy is consumed, order degrades. The accumulation and degradation cycles are driven by entropy gradients, by the second law pulling systems toward disorder. Circadian rhythms don't prove time flows, they prove living systems track thermodynamic asymmetry. Life organizes around entropy's arrow. You're not in thermal equilibrium. You maintain low entropy states complex organization by consuming high entropy energy gradients. Food, oxygen, metabolism is entropy management, taking in low entropy resources, using them to maintain structure, expelling high entropy waste. Life exists in the gap between equilibrium and disorder. In this sense, biological clocks measure entropy change, not time passage. When your body knows it's been 24 hours, it's detecting that certain molecular cycles have completed, that specific entropy changes have occurred. The clock is thermodynamic, not temporal. Time becomes a measure of how much disorder has increased, how far the entropy gradient has progressed. This aligns with Rovelli's thermal time hypothesis. Time emerges from thermodynamics, exists where entropy gradients exist. Your body is a region of significant entropy gradient, food flowing in, waste flowing out, constant energy dissipation maintaining organized structure. Time emerges strongly within your body because entropy changes rapidly there. In block universe terms, your biological clock is a measure of where you are along your world line. It doesn't prove your world line flows through time. It indicates your position in the four-dimensional structure, like mile markers on a highway, indicating position in space. The world line is static, complete. Consciousness reads it sequentially, and biological processes mark positions along it. But aging seems to prove time flows. You were young, now you're older. Cells divide, telomeres shorten, damage accumulates, systems degrade. This is change, undeniable and irreversible. How can this happen in frozen time? The answer? It's geometric. Your world line through space-time curves from birth to death, and along that curve, your body's configuration changes. At early coordinates, young cells, long telomeres, minimal damage. At later coordinates, older cells, short telomeres, accumulated damage. Both exist simultaneously in the block, but they're at different temporal coordinates. Aging isn't the passage of time making you older. Aging is the shape of your world line through space-time. Young at one end, old at the other. with all intermediate stages present simultaneously. Consciousness experiences this sequentially, sliding along the world line, interpreting geometric position as temporal passage. Every organism is a four-dimensional structure extended through space-time. A tree is a long shape starting as seed, growing trunk and branches, eventually dying and decaying. All phases present simultaneously in the block. We perceive the tree temporally because we encounter it at different times, but its entire life is a static four-dimensional object. Your biological clock, then, doesn't prove time flows. It proves your world line has structure, that configurations at different temporal coordinates differ in predictable ways. The clock measures position along the world line, not actual passage through flowing time. Like a thermometer measures temperature without causing heat, biological clocks measure temporal position without requiring time to flow, and yet the experience of aging is undeniably temporal. You feel yourself getting older, feel time passing, feel the relentless forward motion toward eventual death. This feeling is real, even if the underlying geometry is static. Emergence again. Temporal experience from timeless structure. Flow from stillness. Change from eternal configuration. Biology, in the end, neither proves nor disproves time's fundamental reality. It shows that living systems track thermodynamic asymmetry, maintain entropy gradients, cycle through states. We interpret this temporally, but it might be essentially thermodynamic. Life as entropy management in four-dimensional space-time, with biological clocks marking not time's flow but geometry's structure. So your heart beats in frozen time, if time is frozen, or it beats because time flows, if time flows. Both descriptions fit the evidence. Your biological clock ticks forward, but whether it measures flowing time or geometric progression through static space-time remains unanswerable by biology alone. Life happens, that's certain. Whether it happens in time or simply is across time stays mysterious, even as every cell in your body insists it knows what time it is. Now we descend into the mathematical heart of timeless physics, the Wheeler-DeWitt equation. This is where quantum mechanics meets general relativity, where the universe itself becomes the quantum system, and where time vanishes from the fundamental description of reality. It's strange, beautiful, and profoundly challenging to interpret. The equation emerged from attempts to quantize gravity, to describe space-time itself according to quantum mechanics rules. John Wheeler and Bryce DeWitt, working in the 1960s, tried to write a Schrödinger equation for the universe, a quantum mechanical description of all of space-time and everything in it. They succeeded mathematically, producing an equation that does describe quantum gravity, but their equation has no time variable. The standard Schrödinger equation describes how quantum states evolve over time. As pt gives the wave function at time t, Wheeler-DeWitt instead describes the universe as a wave function dependent only on spatial configuration, space, no time parameter, no evolution, just a static wave function describing all possible spatial arrangements of the universe. This isn't an approximation or simplification. It's the natural result of applying quantum mechanics to general relativity. Time in relativity is part of space-time, not separate from it. When you quantize space-time, you quantize time itself, and when time becomes a quantum variable rather than a parameter, it disappears from the equations as an independent entity. Solutions to Wheeler-DeWitt represent entire cosmic histories simultaneously, what physicists call histories or trajectories through configuration space. Each solution describes not how the universe evolves through time, but what complete space-time structures are possible. Past, present, and future exist as a single timeless entity in the equation's solutions. Imagine describing Earth not as a planet orbiting through time, but as a four-dimensional world line, a spaghetti-like structure curving through space-time. Wheeler-DeWitt describes universes similarly, not as three-dimensional space evolving through time, but as four-dimensional space-time structures, complete and static, solutions to a timeless equation. The mathematics work beautifully. Technically, Wheeler-DeWitt reproduces known physics in appropriate limits, classical relativity when quantum effects are negligible, standard quantum mechanics when gravity is weak. It predicts the Big Bang, cosmic expansion, quantum fluctuations. Every testable prediction matches observation, at least in principle, but interpretation remains contentious. If the equation contains no time, What does it mean for things to happen, to change, to evolve? How do we reconcile this timeless description with our undeniable experience of duration? Different physicists answer differently, and no consensus has emerged. Some say time is an emergent phenomenon, appearing at macroscopic scales even though it's absent from fundamental equations. Like how temperature emerges from atomic motion, the atoms don't have temperature, but collections of atoms do. Perhaps time emerges from quantum correlations, from entropy gradients, from complexity in solutions to the timeless equation. Others, like Julian Barber, take the timelessness literally. The universe simply is, all at once, static in its four-dimensional totality. Our experience of time is how consciousness reads this static structure, not evidence that the structure evolves. The Wheeler-DeWitt equation describes reality correctly. Our intuitions about time are what need revision. Still others suggest the equation is incomplete. That time will reappear in more complete theories. Perhaps Wheeler-DeWitt is an approximation, valid in certain regimes but breaking down where time becomes important. Future theories, whatever finally unifies quantum mechanics and gravity, might restore time to fundamental status. But for now, we have this, an equation describing quantum gravity without time, matching observations, producing correct predictions. It's mathematically consistent, empirically adequate, and philosophically radical. The fact that our best attempt to describe the universe at its most fundamental level eliminates time should give us pause. Perhaps time is real but not fundamental. Perhaps it emerges from quantum gravity in ways the equation doesn't yet reveal. Perhaps consciousness creates temporal flow from timeless structure, or perhaps most radically, Wheeler-DeWitt is right, and time truly doesn't exist at the deepest level. Reality is timeless, experience is temporal, both are somehow true. The Wheeler-DeWitt equation won't go away. It's not speculation or philosophical musing. It's rigorous mathematical physics derived carefully from quantum mechanics and general relativity. Whatever time ultimately is, any complete theory must account for why quantum gravity seems fundamentally timeless, while experience seems fundamentally temporal. The equation poses the question starkly: how can we live in time when the universe exists without it? Richard Feynman revolutionized quantum mechanics with a strange and beautiful idea. Particles don't follow single trajectories. They take every possible path simultaneously, with the observed path emerging from interference patterns between all possibilities. This is the path integral formulation, and it offers profound insights into time's nature. In classical physics, a particle travels one definite path from A to B, the path minimizing action following Newton's laws. In standard quantum mechanics, the particle has a wave function describing probability of finding it at different positions. The Feynman unified these perspectives. The particle takes all paths simultaneously, each contributing a probability amplitude, with total amplitude determining what you observe. Every path, straight lines, curved loops, zigzags, paths that go to Jupiter and back, contributes to the particle's behavior. Paths similar to the classical trajectory contribute amplitudes that reinforce each other. Wildly different paths contribute amplitudes that cancel out. The observed behavior emerges from summing over all possibilities, weighted by their probability amplitudes. This is quantum superposition made explicit. Reality isn't one trajectory, it's all trajectories existing simultaneously, interfering with each other. The path we observe results from which paths reinforce versus cancel, not from which path the particle actually took. All paths are real. Observation selects which combination we see. Now apply this to time. In timeless interpretation, path integrals sum over all possible spacetime configurations, not over trajectories through time. Each complete four-dimensional spacetime, each possible arrangement of events from Big Bang to far future, exists simultaneously as a path in configuration space. Reality is the interference pattern between all possible universes. The universe we observe emerges from constructive interference between similar spacetime configurations. Different histories reinforce or cancel based on their probability amplitudes. What we call our universe is the dominant interference pattern in the sum over all possible spacetime structures. Time in this picture becomes a bookkeeping device, a convenient parameter for organizing paths in configuration space, not a fundamental aspect of reality. We describe paths as evolving through time because that's mathematically convenient, but fundamentally all paths exist simultaneously. Temporal sequence is artifact of how we calculate the path integral, not feature of what the path integral describes. Feynman himself was ambiguous about time's reality. He treated it pragmatically in equations, but suggested deeper timelessness might underlie quantum mechanics. When you sum over all paths, you're summing over complete space-time histories, not over temporal sequences. The past and future aren't separate. They're coordinates in the paths being summed. This connects to Wheeler-DeWitt. Both frameworks treat space-time as a complete four-dimensional structure rather than three-dimensional space evolving through time. Wheeler-DeWitt gives the timeless equation. Path integrals give the method for solving it. Together they form a coherent picture of timeless quantum gravity. But doesn't path integral formulation require time to define the paths being summed? Not necessarily. You can formulate path integrals over spatial paths, over abstract configuration spaces, over any space where amplitudes can be assigned. Time is one such space, but it's not special, just another dimension over which paths can be defined. In fact, Euclidean path integrals replace time with an imaginary spatial dimension, making space-time fully four-dimensional space with no temporal character. This trick simplifies calculations and reveals deep connections to thermodynamics. It suggests time might be fundamentally spatial, with temporal character emerging from how we slice through four-dimensional space. The path integral formulation thus supports timeless physics. All possibilities exist simultaneously. All paths are real, and observation selects which combination becomes manifest. This isn't philosophical speculation, it's working physics, used daily by particle physicists to calculate collision outcomes, by condensed matter theorists to predict material properties, by cosmologists to model universe evolution, and it reinforces the block universe picture. If all paths exist simultaneously, all moments do too. If the particle takes every route from A to B, the universe includes every configuration from Big Bang to heat death. Past and future aren't separate from present. They're part of the sum over paths, equally real, equally necessary for calculating what you observe right now. Time becomes, in Feynman's framework, a parameter we use to organize our calculations, not a thing flowing through reality. The paths exist, we describe them temporally for convenience, but fundamentally, all trajectories are eternal, all possibilities permanent, all moments simultaneously real. Reality is the interference pattern, and time is how we read it. If all moments coexist eternally in the block universe or Platonia, if Wheeler-DeWitt describes timeless quantum gravity, if Feynman's paths exist simultaneously, then what is change? How do we explain the undeniable experience of motion, decay, growth, transformation? This is the problem of change, perhaps the deepest challenge facing timeless physics. Our most basic perceptions involve change. You see objects moving, a bird flying, water flowing, clouds drifting. You experience internal change, thoughts arising and passing, emotions shifting, sensations appearing and disappearing. Change seems absolutely fundamental to existence, more certain than anything science tells us about physics. But in timeless physics, nothing changes. The block universe is static. All moments exist eternally, fixed in four-dimensional structure. Platonia is unchanging. All configurations simply are, arranged in timeless mathematical space. Change becomes illusion, or at best, an emergent phenomenon requiring explanation. One answer: change is real but local. At any given temporal coordinate, earlier coordinates differ from later ones. Looking at your world line in the block universe, younger you is different from older you. That's change, variation along the temporal dimension. It's not global change, the whole block universe doesn't alter, but it's genuine local change. You differ at different temporal positions. This is change as geometric variation rather than temporal evolution. Like how a road changes elevation as you travel it, the road isn't transforming. You're moving through space where elevation varies. Similarly, you move through time where configurations vary. The variation is real, the motion is how consciousness experiences the variation. Another answer: change describes relationships between configurations in timeless space. In Barber's Platonia, configurations aren't scattered randomly, they're arranged by similarity. Nearby configurations differ only slightly. Distant configurations differ significantly. Change is the pattern of differences between nearby configurations. When consciousness follows a path through Platonia, it encounters configurations that differ slightly from each other, creating the experience of smooth change. Like flipping through a flipbook, each page differs slightly from the previous, creating apparent motion when viewed sequentially. The pages aren't changing, the sequence creates change experience. A third answer: we're asking the wrong question, conflating map with territory, description with reality. Mathematics describes reality from outside, objectively, timelessly. Experience describes reality from inside, subjectively, temporally. Both are valid perspectives on the same thing, neither more real than the other. The block universe is the mathematical description, objective, complete, timeless. Your experience is the subjective description, temporal, sequential, changing. These aren't contradictory, they're complementary. Like how a novel exists complete as bound pages, objective description, and as unfolding narrative, subjective description. Both are true descriptions of the same object. Perhaps both timeless structure and temporal experience are equally real, equally fundamental, not reducible to each other. Physics describes structure, consciousness experiences flow. Asking which is really real is like asking whether the north or east direction is really real. Both are valid perspectives on space, neither more fundamental. This is perspectivalism about time. Temporal and timeless descriptions are different perspectives on reality, both valid, both real, both necessary for complete understanding. Science gives the timeless perspective, life gives the temporal perspective. Neither is wrong, neither is complete alone, but this seems like giving up, like admitting we can't resolve the contradiction. If physics says nothing changes, and experience says everything changes, claiming both are right doesn't resolve anything, it just accepts the paradox. Yet, maybe paradox is the right answer. Quantum mechanics taught us particles are both waves and particles, contradictory in classical thinking, but both true quantum mechanically. Light is both wave and particle depending on how you observe it. Perhaps time is both flowing and static depending on how you describe it. This would make time's nature fundamentally perspectival, irreducible to single description. The block universe is correct from the mathematical objective perspective. Temporal flow is correct from the experiential subjective perspective. Neither is more true, neither is complete alone. Full truth requires both, held together despite apparent contradiction. The problem of change thus might not have a solution, so much as a dissolution. Change is real experientially, illusory fundamentally, and both statements are true from their respective perspectives. Like how motion in a film is real experientially, you see movement and illusory fundamentally frames are static. The experience isn't invalidated by understanding the mechanism, it's explained. So change happens, undeniably, constantly, everywhere in your experience, and change doesn't happen, provably, mathematically, in physics's deepest descriptions. Both are true, both are real, and the universe is somehow vast enough, subtle enough, mysterious enough to contain both truths simultaneously without contradiction. Perhaps that's what reality is, not single perspective, but the impossible coexistence of incompatible truths, each valid in its domain, together forming something too rich for either alone to capture. Beyond Wheeler-DeWitt, other approaches to quantum gravity independently arrive at timelessness. Loop quantum gravity, string theory, causal set theory, different frameworks, different mathematics, but converging conclusion: time isn't fundamental. Let's explore why physics' deepest theories eliminate time. Loop quantum gravity weaves space-time from discrete quantum loops, not continuous fabric, but network of relationships, like atoms of space itself. Space becomes granular at the Planck scale, 10⁵35 meters, quantized into finite chunks. These loops connect in networks, and space-time emerges from network geometry. Crucially, loop quantum gravity has no background space-time. In general relativity, space-time is dynamic but still a continuous manifold. Loop quantum gravity goes further. Space itself is quantized, emergent from deeper quantum structures, and in this framework, time dissolves. The loops don't evolve through time, They simply exist in quantum superposition of different network configurations. Carlo Rovelli, leading loop quantum gravity researcher, developed relational quantum mechanics partly from this work. He argues time emerges from relationships between quantum systems, exists only where systems interact and become correlated. Isolated systems have no time, just timeless quantum states. Time appears where correlation appears. String theory takes different approach but reaches similar conclusion. It proposes fundamental entities of vibrating strings, not point particles, existing in 10 or 11 dimensions. Extra dimensions beyond our familiar 4 must be compactified, curled up small, unobservable at accessible energies. In string theory's higher dimensional space, time is just another dimension. Nothing special, nothing privileged. The distinction between space and time becomes arbitrary, coordinate dependent. You can rotate between space and time dimensions, treating what's temporal in one frame as spatial in another. Time loses fundamental status, becoming emergent from how we slice through higher dimensional geometry. Moreover, string theory's dualities, mathematical equivalences between apparently different theories, often exchange time for space. A theory describing time evolution can be equivalent to a theory describing spatial variation. This suggests time isn't fundamental but rather a particular way of describing relationships in the underlying structure. Causal set theory proposes even more radical discretization. Space-time consists of discrete events, causal sets related by causal relationships. Space and time aren't continuous. They're networks of events connected by this could cause that links. The causal structure is fundamental. Space-time geometry emerges from counting causal relationships. In causal sets, time emerges from counting. How many causal links separate events determines their temporal distance. Time isn't background against which events occur. It's derived from event relationships. Where there are no events, no relationships, there's no time. Time is relational and emergent, not absolute and fundamental. All these theories, loop quantum gravity, string theory, causal sets, struggle with time's emergence. They successfully eliminate time from fundamental descriptions, but haven't fully explained how temporal experience arises from timeless foundations. This is quantum gravity's hard problem. Not whether time is fundamental, probably it isn't, but how it emerges, still unclear. Why do these different approaches converge on timelessness? Perhaps because they all take seriously quantum mechanics and relativity's implications. Quantum mechanics suggests reality is relational. Particles have properties only relative to observations or interactions. Relativity suggests time is relative, observer-dependent, geometric rather than absolute. Combining these pushes toward timelessness. When you quantize geometry itself, when you treat space-time as quantum system, time can't remain absolute parameter outside the system. It becomes part of what's being quantized, losing its role as independent variable. You get Wheeler-DeWitt equation, quantum state of universe depending on space configuration, but not time parameter. The deeper physics probes, the less fundamental time appears mathematically. At accessible energies, time seems real, absolute, flowing, but at Planck scale, at quantum gravity energies, time dissolves into quantum correlations, network geometry, causal relationships. The mathematics consistently points away from fundamental time. This doesn't prove time isn't real. Emergence is real, but it suggests time emerges from something deeper, something timeless, like how solid matter emerges from quantum fields that aren't solid, or how deterministic laws emerge from probabilistic quantum mechanics. Time might emerge from timeless quantum gravity. Every candidate theory for final physics eliminates time from fundamental description. This remarkable convergence, different approaches, different assumptions, same conclusion, suggests timelessness isn't accident or artifact. It's probably telling us something true about reality's deepest level. There is no time there. Only relationships, correlations, quantum states arranged in timeless mathematical structures from which time somehow, mysteriously, emerges into our experienced world. Does observation create time? Does measurement make moments real? Quantum mechanics requires observers, but who observes observers? These questions connect quantum mechanics' interpretational puzzles to time's mystery, suggesting consciousness might play a central role in temporal flow. Standard quantum mechanics treats time as parameter, not quantum variable. The Schrödinger equation describes how wave functions evolve over time t, but time itself isn't quantized, isn't uncertain, isn't in superposition. It's the backdrop against which quantum events occur, external to the quantum system. But quantum gravity quantizes time itself. Time becomes quantum variable, losing its status as external parameter. Then who or what observes time? If observation collapses wave functions, what collapses time's wave function? We need meta-observers observing time, observing systems, infinite regress. One proposal: consciousness is special, genuinely different from physical processes, capable of collapsing wave functions without itself needing observation. Roger Penrose and Stuart Hameroff suggest quantum processes in neural microtubules might enable consciousness to collapse quantum states, potentially including time itself. In this view, conscious observation literally creates definite moments from quantum superposition of different times. Before observation, quantum blur of multiple temporal states. After observation, definite now selected by consciousness. Time flows because consciousness continuously collapses temporal superposition, generating sequential definite moments. This is deeply controversial. Most physicists reject consciousness as special physical entity, but Penrose argues gravity itself might cause wave function collapse, with consciousness accessing this process through quantum effects in neurons. If true, observation might genuinely create temporal flow through orchestrated objective reduction or theory. Alternative approach: observation is just entanglement, no consciousness needed. When quantum system interacts with environment detector, photon, anything, it becomes entangled, creating correlated records. This decoherence makes superposition practically unobservable, creating appearance of collapse without requiring actual collapse. In this view, time emerges from correlation accumulation. Each interaction creates records, entanglements, information spreading through environment. Time is correlation history, the pattern of how quantum states became entangled over interactions. Where there's no entanglement, no interaction, there's no time. This explains time's arrow thermodynamically. Entanglement increases entropy information spreading irreversibly. The direction of increasing entanglement defines time's direction. Past is low entanglement state. Future is high entanglement state. Observation doesn't create time, it participates in correlation accumulation that is time. But what about the observer itself? If observation is entanglement, and entanglement creates time, who observes observers? The environment. Everything observes everything through continuous quantum interactions. No privileged observer needed, just universal entanglement network, where every system observes every other system it interacts with. This is quantum Darwinism. Certain information like position becomes multiply redundant across environment through decoherence, making it appear objective. You observe definite particle position because environment already observed it through countless interactions, creating redundant records. Objectivity emerges from redundancy, not from consciousness. Time might work similarly. Temporal order emerges wherever systems interact sufficiently to create correlated records. Different systems might experience time differently depending on interaction complexity. Your brain processing enormous information generates strong temporal experience. Isolated particles barely interacting might have weak or no temporal experience. Observation, whether conscious or merely entangling, creates mutually consistent records. Your memory of measurement outcome correlates with detector's record, correlates with particle's final state. This correlation network defines temporal ordering, what happened before what, without requiring time to flow. It's timeless correlation creating temporal appearance. Yet phenomenologically, observation feels temporal. You experience measuring something, then knowing the result. The sequence seems real, undeniable. Even if underlying correlations are timeless, experience is sequential. So observation either creates time or creates time experience from timeless correlations. Perhaps consciousness doesn't collapse waves, but rather integrates information in ways that generate temporal flow experientially. Your brain processes quantum information from environment through decoherence, not consciousness, integrates it into unified experience, and this integration feels temporal. Time is how integrated information processing feels from inside. This makes observation central without making consciousness special. Any sufficiently integrated information processing system, brain, AI, maybe sufficiently complex detector, would generate temporal experience. Observation creates time subjectively, how processing feels, while merely participating in timeless correlations objectively, what's actually happening. So observation might create time, or record time, or simply participate in timeless correlations we interpret temporally. All interpretations fit current physics. None is definitively proven, but the deep connection between observation and temporality suggests they're intimately linked. Understanding one requires understanding the other. Time might be what observation is, how correlated records feel from inside systems, complex enough to integrate them. Or observation might be what time requires, how timeless correlations become temporal experience. Either way, separating them seems impossible. If the future exists now, already laid out in spacetime's four-dimensional structure, are your choices predetermined? Does the block universe eliminate free will? This question troubles people encountering eternalism, but the answer is subtler than simple yes or no. Let's explore why. First, clarify terms. Determinism means future states follow necessarily from past states according to physical law. Eternalism means all moments past, present, future exist with equal ontological status. These are different claims. Determinism is about causation. Eternalism is about existence. You can have one without the other. Classical physics is deterministic. Given complete information about now, physical law determines all future states uniquely, but quantum mechanics introduces genuine randomness. Particles sometimes do unpredictable things, not from ignorance but from fundamental indeterminacy. So the universe might be eternalist, all moments exist without being deterministic, future isn't uniquely determined by past. But doesn't the block universe mean your future is already there, fixed, unchangeable? Yes, but that doesn't eliminate free will. Consider, your future choices might be free even if they're timelessly embedded in space-time structure. The fact that they exist eternally doesn't mean they're caused by anything other than your decision-making process. Analogy: a map shows your entire journey, starting point, route, destination. The journey exists complete on the map, but you still chose the route. The map's completeness doesn't retroactively eliminate your choices, it records them. Similarly, spacetime's block structure records your choices eternally, but recording isn't determining. Your decision-making process is part of spacetime's structure. When you choose, you're not fighting against predetermined future. You're creating the future that exists in the block. Your choice is why the future is what it is. The choice and its outcome are both eternally present, causally connected, with choice determining outcome, even though both exist timelessly. Think of it like a novel. The story exists complete, all events present simultaneously in the bound book. Characters' choices are recorded on pages, outcomes following from choices. Yet within the narrative, choices are genuine. Characters decide, outcomes follow from decisions. The story's completeness doesn't make choices fake. It contains genuine decision points. You are four-dimensional structure in space-time, extended from birth to death. At each temporal coordinate, you make choices based on information, preferences, reasoning. These choices are part of your world line's geometry, determining its shape. Your world line is complete, yes, but its shape is what it is because of choices you make at each moment. Freedom, in this view, isn't about having alternative possibilities branching into open futures. It's about your decisions being what determines which complete space-time structure is actual. The structure is fixed, but fixed by your choices, not fixed despite them. You're authoring the novel as you're reading it, even though the complete novel already exists. This compatibilist position, free will and determinism both real, feels unsatisfying to some. They want free will to mean genuine openness, multiple possible futures, the ability to do otherwise. Block universe seems to eliminate precisely this. If future exists already, you can't do otherwise because otherwise doesn't exist. But consider, even in open future scenarios, you also can't do otherwise than what you do. When you choose A over B, you chose A, that's what happened. Saying you could have chosen B means only that choosing B was consistent with physical law and your decision-making capacity, not that some alternate universe contains you choosing B. The block universe makes explicit what's always true. At each moment, one thing happens. Your experience is of this happening, not of multiple possibilities simultaneously real. Whether future is open or fixed, you experience making choices and outcomes following. The experiential structure is identical. Perhaps free will is compatible with eternalism, because free will isn't about metaphysics, it's about psychology and ethics. You have free will if your actions follow from your deliberation, reflect your values, aren't coerced by external forces. This is true regardless of whether all moments exist eternally or futures are open. Your choices matter eternally in block universe. Every decision is permanent feature of space-time structure, forever affecting what comes after. This doesn't diminish importance, it enhances it. Your free choices are eternal, unchangeable aspects of reality's geometry. You are co-author of the universe's shape, so are choices predetermined. Depends on definition. They're pre-existent in space-time's block, yes, but they're not predetermined by anything other than your decision-making process. Freedom and fixedness coexist paradoxically. Your choices are free, caused by your deliberation, and fixed, eternally embedded in space-time. Both descriptions are true, both compatible, both real. The paradox resolves, or at least becomes livable, when you see freedom as internal causation rather than external openness. You're free if your actions follow from your choices, and they do eternally. Does life lose meaning if past and future are equally real? If nothing progresses, nothing develops, nothing moves toward goals, what's the point? This existential concern often arises when confronting eternalism, but perhaps meaning deepens rather than disappears when we see time differently. Traditional meaning-making assumes progression. You start somewhere, work toward goals, achieve outcomes, progress. Meaning comes from growth, development, becoming better or wiser or more complete. This requires genuinely open future, real change, improvement through time. How can life mean anything if it's static, complete, unchanging? But consider, every moment matters eternally, not just fleetingly. That conversation yesterday, still happening forever at its temporal coordinate. The joy you felt, eternal, permanently real, unchangeably part of space-time structure. Nothing is lost, nothing fades, nothing becomes merely memory. Everything that happens stays happened, eternally present in the block. This transforms loss from erasure to distance. Your loved ones who've died haven't vanished into non-existence. They remain where they always were, at temporal coordinates you can't revisit. They're spatially distant other place and temporally distant other when, but no less real. Grief becomes longing for adjacent configuration rather than mourning absolute absence. Your younger self exists, still experiencing those moments that feel long ago to you. Every version of you across your entire lifetime is real, present, experiencing its moment. You're not a point moving through time. You're a four-dimensional structure with young end and old end, entire shape existing complete. Every moment of your life is eternally you. This reframes mortality. You don't cease to exist when you die. You're simply bounded temporally as you're bounded spatially. You exist from birth coordinate to death coordinate, extended through four-dimensional space-time. Death isn't end of existence, but boundary of existence. Like how your skin isn't end of you, but boundary of you. Nothing truly begins or ends in timeless universe. Configurations simply are, arranged in patterns consciousness interprets as beginnings and endings. A candle burning is static four-dimensional shape. Tall intact candle at one temporal end, melted puddle at other temporal end. The entire shape exists complete. We interpret it temporally, experiencing it sequentially, but it is whole, eternal, unchanging in its completeness. So meaning doesn't require progression because meaning comes from what is, not from what becomes. Your relationships matter because they exist, not because they develop. Your choices matter because they shape space-time's geometry, not because they open futures. Your life means something because it is a permanent pattern woven into reality's fabric, not because it moves toward anything. In fact, meaning might deepen an eternalist view. Traditional progression-based meaning makes everything temporary. Joy is fleeting, love is temporary, life is brief spark. But eternally existing moments aren't fleeting, they're permanent. Your life isn't brief, It extends 40, 60, 80 years through space-time's temporal dimension. That's not brief, that's substantial. Every moment of beauty you experience exists forever. Every connection you make is eternal. Every bit of suffering you endure is permanently real, but also permanently over. It exists at its coordinate, but you move past it to later coordinates where it's no longer present for you. The good is eternal, the bad is eternal, but bounded. This might seem cold comfort. Eternally existing doesn't feel the same as continuing to experience. Your dead loved ones exist forever at their coordinates, but you can't interact with them anymore. You're at different temporal positions. The eternalism makes philosophical point but doesn't ease emotional pain. Yet there's something here worth contemplating. Traditional view says past is gone, future non-existent, only present real. This makes everything except this moment unreal. Eternalism says everything is equally real, all moments mattering, all experiences permanent. Which view actually diminishes meaning? Perhaps meaning requires both progression experientially and permanence structurally. You experience progression, goals pursued, growth achieved, life developing. This is real, important, meaningful, but underlying this experience is timeless structure where all moments exist eternally, making everything permanently meaningful rather than temporarily significant. The universe doesn't need to progress to mean something. A completed painting means something. Its meaning isn't about changing into something else. A novel means something complete, beginning to end, not progressing but existing as meaningful whole. Perhaps life is similar, meaningful as complete four-dimensional structure, not as progression toward uncertain future. Your life is meaningful because it is, not because it becomes. You shape space-time eternally through your choices. You create beauty that exists forever. You form connections that never cease being real. Every moment matters permanently. Every choice creates eternal consequences. Every experience is forever part of the universe's structure. So meaning without progression is meaning as being rather than becoming. It's meaning as eternal contribution to reality's fabric, rather than temporary movement toward goals. It's meaning found in what you are, four-dimensional structure extending through space-time, shaping universe's geometry, existing permanently, rather than what you're becoming. And perhaps that's enough. Perhaps that's more than enough. Perhaps that's everything meaning could be. Why does waiting feel slow while excitement rushes past? Why do childhood summers last forever while adult years fly by? These puzzles about subjective time reveal something profound. Time is partly cognitive construction, brain-generated sensation like color or pain. Understanding this illuminates what time might fundamentally be. Your brain doesn't passively register time passing. It actively constructs temporal experience from non-temporal information. Neural signals are timeless chemical and electrical patterns. Your brain imposes time on them, organizing signals into now, just past, upcoming, creating experience duration from timeless correlations. Consider the 3-second present moment. Your brain integrates sensory signals arriving across roughly 3 seconds, unifying them into coherent now. But those signals don't come marked with timestamps. Your brain infers temporal order from causal relationships, signal intensities, neural processing sequences. Time is constructed, not observed. This construction varies based on attention and information density. When you're bored, few novel signals arrive. You're not processing much new information. Your brain notices this poverty, interprets it as long duration. More attention to time itself makes it feel longer because you're generating more temporal markers, more moments of awareness per objective duration. Conversely, engagement floods your brain with novel information. Processing this information occupies cognitive resources that might otherwise track time. You generate fewer temporal markers because you're focused on content, not duration. Afterward, the period feels brief despite containing rich experience. This explains childhood versus adult time perception. Children experience everything as novel. World is new. Every experience information-rich. Their brains generate many temporal markers, making duration feel long. Adults encounter fewer novelties, process less new information, generate fewer markers. Objective time passes identically, but subjective duration compresses. Memory compounds this. Rich memories contain many distinct moments. making past periods recall as long. Routine periods leave few distinct memories. Recalling as brief, your 30s might feel faster than your 20s, partly because you remember less distinctly, fewer novel experiences worth encoding densely. Neurologically, time perception involves multiple brain regions: hippocampus for sequence, striatum for interval timing, prefrontal cortex for temporal planning. These regions don't measure time directly. They track changes, count events, estimate durations from accumulated neural activity. Time emerges from this distributed processing, not from dedicated clock. Drugs alter time perception dramatically. Marijuana makes minutes feel like hours. THC affects neural timing circuits, changing how events are sequenced and counted. Psychedelics can dissolve temporal experience entirely. Users report timelessness, eternal now, sequential time stopping. These effects reveal time's neurological dependence. If time were fundamental, drugs couldn't alter its perception. You can't make fundamental constants different through chemistry, but you can't alter neural processing, change how brain constructs temporal experience. The fact that time dilates or contracts with neural state suggests time is neural construction, not direct perception of objective flow. This doesn't mean time is merely subjective illusion. Temperature is brain-generated sensation too. Atoms have kinetic energy, not temperature. Yet temperature is real, objective, measurable. Similarly, time might be brain-generated sensation of real thermodynamic processes, real entropy changes, real configuration transitions in space-time. Your brain creates temporal qualia, what it's like to experience duration, for navigating thermodynamic gradients through four-dimensional space-time. You're a four-dimensional being, but consciousness only illuminates three spatial dimensions plus one temporal coordinate at any instant. Temporal experience is how your brain represents your position in the fourth dimension. Just as color qualia help you navigate wavelength variations, red, long wavelength, blue, short, temporal qualia help you navigate configuration changes, past, lower entropy, future, higher entropy. Both are constructed sensations of real physical properties, making those properties experientially accessible for organisms navigating complex environments. Reality might be timeless at base. No flow, no duration, just static configurations or timeless quantum correlations. But brains evolve to track changes, sequence events, anticipate futures. This required constructing temporal experience, even if underlying reality isn't temporal. Time emerged in consciousness because it's useful, not because it's fundamental. This explains individual variation. Your time experience differs from mine because we have different brains processing information differently. It explains species variation. Flies experience time faster, more perceived moments per second. Turtles slower. It explains time's malleability, boredom and excitement, childhood and age. Drugs and meditation all alter duration by changing neural processing. The experience of duration is real. It affects behavior, enables planning, creates meaning, but it's cognitively constructed from non-temporal ingredients, like how wetness emerges from molecular interactions. The construction doesn't make experience fake, it makes experience emergent. And emergence, as we've seen, is how complexity creates genuine novelty from simpler foundations. So when you wonder whether time is real or illusory, consider your experience of duration is real subjectively, emergent structurally, constructed neurologically, and possibly revealing timeless reality through cognitive filtering. All these are simultaneously true. Time is real as experience, questionable as fundamental entity, understood as neural construction representing something deeper we navigate without directly perceiving. If everything that happens exists eternally, what is loss? When someone you love dies, where do they go? In block universe terms, nowhere. They remain at the temporal coordinates they always occupied. Yet you grieve profoundly, undeniably. Let's explore this paradox: eternal presence and experienced absence. Your loved ones, in eternalist view, don't vanish when they die. They exist completely, eternally, at their temporal locations, every moment of their lives present forever in space-time structure. Their childhood, their laughter, their final breath, all permanently real, unchangeably embedded in four-dimensional reality. but you're no longer at overlapping temporal coordinates. Your world line and theirs diverged. They ended while yours continues. You exist at coordinate where they no longer exist, where your world lines don't intersect. Like being in different countries, both countries exist, both are real, but you can't interact across distance. Grief in this view is longing for adjacent configurations rather than mourning absolute erasure. You can't access temporal coordinates where they exist, because you're bound to your current coordinate. Moving forward along entropy's arrow, they're not gone from existence, they're inaccessible from your present position. This offers cold comfort, perhaps, knowing they exist eternally somewhere. When doesn't ease the pain of not being able to talk to them, touch them, share present moments. The distance is absolute. You can't travel backward in time any more than you can travel to yesterday's position in space by moving spatially. Yet there's something here worth contemplating in quiet moments. Everything that ever was still is just elsewhere in the block. Every conversation you had exists forever. Every moment of love shared is eternally real. Nothing is erased. Nothing becomes non-existent. The past isn't gone. It's behind you in the temporal dimension, as real as places you've traveled away from are behind you spatially. Your loved one is still experiencing their life at their coordinates. To them, eternally, it's now. They're still laughing, still loving, still being themselves. You're temporarily distant from those moments, but the moments are no less present. From perspective outside time, you and they exist simultaneously. Your entire world lines coexisting in spacetime's complete structure. This reframes death from ending to boundary. Your loved one's world line has definite terminus at their death, like your body has boundaries at your skin, but the bounded structure exists completely, eternally. They lived, they are that living, timelessly present in its entirety. Death is where their world line ends, not where they cease to be, and they're not alone in non-existence, because they're not in non-existence. They're in existence, at their coordinates, experiencing their moments. You're simply at different coordinates now, unable to share moments anymore. The separation is spatial temporal distance, not one person existing while the other doesn't. But, and this is crucial, eternalism doesn't diminish grief. Loss is loss, the inability to share new moments, to continue growing together, to remain connected. These are real deprivations. The fact that past moments exist eternally doesn't create new moments. You're separated by time's arrow, and that separation hurts. Perhaps grief reveals something about consciousness's relationship to time. You experience loss because you're embedded in time, moving through it, unable to revisit earlier coordinates. If you could perceive timelessly, see all moments at once, experience your entire world line simultaneously, perhaps grief would transform into something else. Sadness at world lines diverging, perhaps, but not loss, not absence. But you can't perceive timelessly. You're bound to your current coordinate, experiencing sequentially, moving forward. This makes loss real experientially, even if logically it's distance rather than disappearance. The experience is what matters for beings like us, embedded in time, unable to escape its flow. Still, eternalism offers perspective that might ease grief's sharpest edges. Your loved one's life was real and remains real forever. They achieved full existence, complete from beginning to end. They experienced love, joy, meaning. All of that exists eternally, unchangeably part of reality's fabric. They didn't cease being, they completed being. And you carry them forward. Your memories are correlations between your current brain state and earlier states when they existed. In block universe terms, your world line remains entangled with theirs through memories. They continue affecting your trajectory, even though your world lines no longer overlap. Their existence shaped yours permanently. Everything that ever was still is, just elsewhere in the block. This is both comforting and terrifying, both profound and empty. It doesn't erase grief but might transform it. Not they're gone forever, but they're there forever, and I'm here. Not absolute loss but absolute distance. Not erasure but inaccessibility. The pain might be similar, but the metaphysics are different. And sometimes in grief's depths, metaphysics matter more than we'd expect. What does it mean to create if everything already exists? What is destruction if nothing truly ends? These questions arise naturally from eternalism. challenging our concepts of making, unmaking, beginning, ending. Let's reimagine these fundamental processes through the lens of timeless physics. Nothing truly begins or ends in timeless universe. Configurations simply are, arranged in patterns consciousness reads sequentially. A candle burning isn't changing from tall and unlit to short and melted. It's a static four-dimensional shape, tall at one temporal end, short and melted at the other temporal end, with all intermediate stages present simultaneously. The entire shape exists complete, candle at all moments, extended through time like it's extended through space. We interpret this temporally because consciousness moves along the candle's world line, encountering tall candle configurations before short candle configurations. But the interpretation is ours. The candle simply is its complete four-dimensional form. Creation, then, isn't making something from nothing. It's being the process whereby certain configurations come to exist in space-time structure. When you create art, you don't make reality change from art absent to art present. You enact configurations where art exists. The art was always there in the complete space-time block. Your creative process is part of what makes it there. This sounds like fatalism. If art already exists in space-time, why create? But the logic reverses. Art exists in space-time because you create it. Your creative acts are why certain configurations are actual, rather than merely possible. You're not discovering pre-existing art. You're authoring the space-time structure that contains art. Consider writing a novel. From outside perspective, the completed novel exists, all words present on pages, beginning to end. Characters make choices, plots unfold, story resolves. Does the author create this or merely discover it? Both. The author creates by discovering what the characters would do, what the story requires. Creation and discovery merge when authoring timeless structures. Similarly, you create by enacting configurations that exist timelessly. Your creation makes those configurations actual, present in space-time's geometry. They always existed in the sense that all space-time moments exist simultaneously. But they exist because you created them, not despite your creation. The causality runs from creating to existing, even though both are eternal. Destruction seems paradoxical too. How can you destroy what exists eternally? A broken glass exists as broken glass configuration, just as much as the intact glass exists as intact glass configuration. Both are present in space-time, at different temporal coordinates. Yes, but equally real. Yet destruction is real experientially. You experience glass transforming from intact to broken, witness configurations changing from organized to disordered. This is genuine change, not in space-time's total structure which is complete and unchanging, but in sequential experience of that structure. Destruction describes how configurations differ along world lines. In Barber's Platonia, destruction describes motion through configuration space from low entropy to high entropy regions. The glass intact configuration and glass broken configuration both exist as points in Platonia. Consciousness follows paths connecting them, experiencing transition as destruction. But both configurations exist eternally. Destruction is the path between them, not elimination of one. This makes destruction geometric rather than eliminative. The intact glass doesn't cease existing. It exists at earlier temporal coordinates, eternally. The broken glass doesn't suddenly spring into existence. It exists at later temporal coordinates, also eternally. Destruction is the space-time geometry connecting these configurations, the world-line shape between them. Creation and destruction become navigation descriptors rather than ontological processes. You navigate through configuration space, through space-time, encountering different arrangements. Creation means moving into regions where things exist that didn't exist earlier in your world line. Destruction means moving into regions where earlier things no longer exist in your present. But from timeless perspective, nothing is created or destroyed. All configurations coexist. Time's arrow creates appearance of creation and destruction. By ordering your experience of eternal configurations, you encounter intact glass before broken glass because entropy increases that direction. The ordering is thermodynamic, not ontological. Yet creation and destruction matter tremendously to beings like us. Embedded in time, experiencing sequentially, you create meaning, art, relationships. These matter even if they exist timelessly. You witness destruction, loss, decay. These pain you even if destroyed things exist eternally at earlier coordinates. The eternal presence doesn't diminish temporal significance. Perhaps creation is best understood as shaping. You shape space-time's geometry through your actions. When you create, you determine what four-dimensional structures exist, what patterns emerge, what configurations are actual. The creating and the created are both eternally present, but one causes the other, even in timeless framework. Destruction, conversely, is divergence. Your world line diverges from configurations you're destroying. They continue existing where they were, but your trajectory moves away from them. Like leaving a place, the place doesn't cease existing, but you're no longer there. Destruction is separation in time rather than elimination from existence. So creation and destruction remain meaningful as processes we experience, shapes we enact, paths we follow through eternal configuration space. Nothing begins in absolute sense, nothing ends absolutely. But relative to consciousness moving through space-time, creation and destruction are real, significant, powerful processes shaping experience even if underlying reality is static, eternal, unchangingly complete. Not everyone accepts timeless physics. Some researchers argue time is real but emergent, arising from deeper processes rather than being fundamental. Let's explore how time might emerge from information theory, quantum correlations, and thermodynamic processes, creating genuine temporal flow from timeless foundations. Just as solidity emerges from quantum fields, atoms aren't solid, but collections of atoms are. Time might emerge from information-theoretic processes. When quantum systems entangle and decohere, they create correlated records throughout environment. These records are memories, physical states encoding information about earlier states. Each interaction creates such records. Photon hits atom, leaving both changed in correlated ways. These correlated states propagate through environment. Photon affects next atom, original atom affects neighbors. Information spreads. The network of correlations grows denser, more complex, more irreversible. Entropy ensures correlations point one direction. Creating records increases entropy. Information spreads, energy dissipates, order degrades. You can create records of earlier states' memories, but not later states' predictions. Because recording requires low to high entropy processes, this asymmetry defines time's arrow emergently. Time emerges wherever such record keeping occurs. In regions with no interactions, no decoherence, no correlation accumulation, there's no time, just isolated quantum states in superposition. But wherever systems interact sufficiently, time crystallizes from correlation networks. It's local, relative, emergent, rather than global, absolute, fundamental. This explains why time feels so real. You're immersed in dense correlation network. Your brain creates constant records, memories, sensory integration, predictive models. This record-keeping generates strong time experience. You exist in region where time has fully emerged from information-theoretic processes. Different cosmic regions might experience time differently. Near black hole event horizons, where entropy gradients are extreme, time might be severely distorted or partially emergent. In cosmological voids between galaxy clusters, where few interactions occur, time might be weakly emergent. Deep in quantum foam at Planck scale, time might not emerge at all. This makes time perspectival rather than universal. There's no absolute now-spanning universe. Time emerges independently in different regions based on local interaction density. Your time is human-scale time, strongly emergent from biological complexity. Other scales, other densities might experience time differently, or not at all. The emergent time hypothesis preserves both timeless fundamental physics and temporal experience. Wheeler-DeWitt equation describes timeless quantum gravity accurately, but in appropriate limits, many particles, high interaction rates, significant decoherence, time emerges naturally from the timeless framework. Both descriptions are valid at their respective levels. This is similar to how thermodynamics emerges from statistical mechanics. Individual atoms don't have temperature, but collections do. The atoms obey time-reversible equations, but thermodynamics describes irreversible processes. Both levels are real. Higher level emerges from lower levels complexity. Critics argue emergence doesn't fully explain time. How do timeless quantum correlations become temporal experience? What makes correlation accumulation feel like flow? Why does consciousness experience sequence rather than timeless pattern? Emergent time theories haven't fully answered these questions. Proponents respond that these are hard problems of consciousness, not problems specific to time. Any physical process, temperature, color, pain, faces similar gaps between objective description and subjective experience. Time isn't special in having this gap. Consciousness is what's mysterious. Emergence also explains time's multiple arrows, thermodynamic entropy increase, psychological memory of past, causal effects follow causes. All these emerge together from correlation accumulation and entropy gradients. They're different aspects of same underlying information theoretic process, creating coherent time experience from multiple convergent emergence pathways. If time emerges, it's genuinely real, not illusion, not approximation, but real higher-level property of complex systems. Like how life is real even though atoms aren't alive, or how liquidity is real even though molecules aren't liquid. Emergence creates genuine novelty, properties that don't exist at lower levels but are completely real at higher levels. So time might be emergent, arising from quantum correlations, decoherence, and entropy gradients rather than existing fundamentally. This preserves timeless quantum gravity while explaining temporal experience. Both are true, timelessness below, temporality above, with emergence bridging them. Reality layered, time emerging where complexity allows, consciousness experiencing the emergent layer we're embedded in. Not everyone accepts eternalism, presentism, the view that only the present exists, with past gone and future unborn, refuses to die despite relativity's challenges. Let's explore why presentism appeals philosophically and whether it can survive physics' attacks. Presentism fits experience perfectly. Right now feels uniquely real. The past seems gone. You can't interact with it, only remember it. The future seems non-existent. You can't access it, only anticipate it. Only now appears concretely real, with past and future as abstractions, not actualities. Philosophically, presentism preserves genuine change. If only present exists, then past genuinely doesn't exist anymore. It existed but doesn't now. Similarly, future doesn't exist yet. It will exist but doesn't now. Change is real creation and destruction, not merely different coordinates in eternal spacetime. This makes time's flow fundamental rather than illusory. Moments come into existence, persist briefly as present, then cease existing as they become past. Reality is dynamic, evolving, genuinely temporal rather than static four-dimensional structure. Time doesn't just feel like flow, it is flow. Presentism also preserves intuitions about freedom and openness. If future doesn't exist yet, it's genuinely open, not determined, not fixed, not waiting somewhere to be discovered. Your choices create future, bring it into existence, rather than merely selecting which eternal future you inhabit. But relativity attacks presentism brutally. Einstein showed simultaneity is relative. Observers moving differently disagree about which distant events are happening now. There's no universal present moment. If only present exists, who's present? The one you're experiencing. Someone moving differently experiences different present. This seems fatal. If simultaneity is relative, then the present moment is observer-dependent. Different observers have different present moments. But if only present exists, and different observers have different presents, what actually exists? Everything, nothing. The question becomes incoherent. Presentists respond various ways. Some accept that reality is observer-dependent. Different frames have different present moments, all equally real. This makes existence frame relative. What exists for you differs from what exists for differently moving observer. Strange, but perhaps not incoherent. Others argue relativity doesn't actually prove simultaneity. Relativity, perhaps there's absolute simultaneity we haven't discovered. Privileged frame defining true present moment. This contradicts standard relativity interpretation, but isn't logically impossible, just empirically unmotivated. Still others suggest present isn't instant but duration, thick present spanning some finite interval. Different observers might disagree about exact simultaneity, but agree roughly about what's present. This preserves presentism's spirit, while accommodating relativity and hybrid relativity. The deeper problem, quantum mechanics and general relativity converge on timeless descriptions. Wheeler-DeWitt, path integrals, emergent space-time, all work without fundamental time. If best physical theories are timeless, presentism fights uphill against empirical adequacy, not just philosophical preference. Yet the appeal persists. Perhaps experience reveals deeper truth than mathematics. Perhaps consciousness accesses reality directly in ways physics doesn't capture. Perhaps the present's undeniable reality indicates ontological truth physics hasn't yet recognized. Some philosophers argue for epistemic presentism, if not ontological. We only know the present directly, only experience now immediately. Past is known through memory states existing now. Future is known through anticipation states existing now. All knowledge is present-centered, even if past and future exist. This weaker presentism accepts eternalism ontologically, while preserving presentism's phenomenological insights. Reality might be four-dimensional block, but knowledge and experience are present-focused. Both eternalism and presentism capture different truths, one about structure, one about experience. The debate remains unsettled. Eternalism has physics authority, relativity, quantum gravity, path integrals all support it. But presentism has experience's immediacy, the felt reality of flowing time, the obviousness of present's uniqueness, the intuition that past is gone and future unborn. Perhaps both are true differently. Eternalism correctly describes spacetime's mathematical structure. Presentism correctly describes temporal experience. Or perhaps future developments. Quantum gravity's completion, consciousness science's maturation, will favor one decisively. For now, presentism survives as philosophical position, even as physics leans toward eternalism. The present's reality remains undeniable, even if its existence remains debatable. Between eternalism and presentism lies compromise, the growing block universe. Past and present exist, future doesn't yet. Reality accumulates, crystallizing moment by moment like spreading frost. Let's explore this middle position's appeal and challenges. Growing block preserves change while granting past reality. The past isn't gone, it exists, permanently, like eternalism claims. But future doesn't exist yet. It's genuinely open, like presentism claims. Only present is special, the boundary where non-existent future becomes existent present, then past. This feels natural. You experience past as real. Memory accesses it. History records it. It affects present causally. You experience future as unreal. It hasn't happened. You can't remember it. You can only predict it uncertainly. The asymmetry between past fixed real, actual and future open, unreal, potential matches experience perfectly. Growing block also explains time's arrow naturally. The universe literally grows in temporal dimension, accumulating more existence as time passes. The arrow is the direction of growth, the edge where being spreads into non-being. Past is dense with being. Future is void awaiting being. Time flows because reality itself is flowing, expanding, creating. Change becomes genuine. When something happens, being increases. The universe becomes larger, more extensive temporally. The present moment is where this creation occurs, where potential becomes actual, where future transforms into past. Change isn't illusion or relocation in static space-time. It's literal creation of new existence. This preserves free will intuitively. If future doesn't exist yet, your choices aren't predetermined by already existing future states. You create future through decisions, bring it into being through action. The openness is real, not merely apparent. You're genuinely authoring reality's expansion, but growing block faces severe problems. First, what's the edge of existence? What makes one moment the present where being stops? In relativity, there's no universal present moment. Different observers disagree about what's simultaneous. Whose present is the edge? Where does being terminate? This is presentism's relativity problem repackaged. If the edge is observer-dependent, different frames have different edges, and being is frame-relative. If the edge is absolute, we need privileged frame contradicting relativity. Either way, physics challenges the concept. Second problem, what explains the growth? Why does being spread temporarily? What mechanism pushes the edge forward? Traditional eternalism has no growth to explain. Everything simply exists timelessly. Presentism has continuous existence to explain. Only present exists continuously. But growing block needs explanation for why past accumulates, why present keeps becoming. Some suggest quantum measurement causes growth. Observation collapses wave functions, making potential actual, adding being to block. But this requires controversial interpretations of quantum mechanics and doesn't clearly explain continuous temporal growth. Others propose growth is primitive, fundamental process requiring no deeper explanation. Time's passage is basic feature of reality, not reducible to anything else. This abandons the explanatory project, but preserves growing block structure. Third problem, the accumulated past seems causally inert. If past exists but present is special, what makes present special? Why can't past moments act causally like present ones? What's ontological difference between existent past and existent present that makes only present causally efficacious? Growing block proponents struggle with these questions. Some say only present is causally active because only present is becoming, the past has become, the present is becoming. But what is becoming ontologically? It's hard to specify without circular appeals to time itself. Despite problems, growing block remains popular, especially among philosophers emphasizing temporal experience. It captures intuitions, eternalism and presentism, each miss, past reality against presentism and future's openness against eternalism. If philosophy could legislate reality, growing block might be consensus choice, but physics leans against it. Relativity challenges privileged present. Quantum gravity suggests timeless foundations. Thermodynamics explains asymmetry without requiring accumulation. The theoretical case for growing block is weak, even if experiential case is strong. Perhaps growing block is psychologically natural but physically unmotivated. How temporal experience feels, not how reality is structured, or perhaps its transitional position, unstable middle ground destined to collapse toward eternalism or presentism, or perhaps it reveals something real that physics hasn't yet captured. For now, the block grows in philosophical imaginations, if not physical space-time. The edge between existent and non-existent remains mysterious, possibly incoherent, but phenomenologically compelling. Reality accumulating, crystallizing, spreading through time's dimension. It feels true even if proving true remains elusive. Space-time might not be continuous fabric. It might be fundamentally discrete, not smooth geometry but network of causal relationships, like atoms of occurrence. This is causal set theory, and it offers radical reconception of space, time, and their relationship. Imagine space-time not as smooth, four-dimensional manifold, but as a collection of discrete events, points where something happens, moments of occurrence. These events aren't embedded in background space-time. They are space-time's fundamental constituents. Space and time emerge from counting events and their causal relationships. Each event can cause some future events, and was caused by some past events. These causal relationships, this could influence that, form network structure. Events causally related are linked. Events not causally related are separate. The network of causal links is fundamental. Geometric distance emerges from counting links. Space emerges from how many causally unrelated events fit between two events. If many events are simultaneous not causally related between A and B, they're far apart spatially. If few events fit between them, they're close spatially. Space is measure of causal independence. Time emerges from counting causal links. If event B requires many causal steps from event A, many intermediate events linking them, they're far apart temporally. If few steps separate them, they're close temporally. Time is measure of causal depth, number of cause-effect steps linking events. This makes time intrinsically relational and emergent. There's no background time through which events move. Time is the causal structure itself, the pattern of which events causally influence which others. Where there are no events, no causal relationships, there's no time either. Time exists only where causal networks exist. Causal set theory avoids continuous time's quantum gravity problems. General relativity treats space-time as smooth, infinitely divisible. But quantum mechanics suggests everything is discrete, quantized at smallest scales. Reconciling continuous geometry with quantum discreteness is hard. Causal sets bypass problem by making discreteness fundamental. No background geometry means no preferred time dimension. Space and time emerge together from causal structure, neither privileged. The distinction between space causal independence and time causal depth is emergent from network properties, not fundamental division. This explains time's arrow naturally. Causal relationships point one direction. Causes precede effects. Effects follow causes. This ordering is built into causal network structure, making temporal asymmetry fundamental rather than emergent from entropy or cosmology. Critics argue causal sets don't yet reproduce general relativity fully. The theory predicts right space-time geometry in many limits but struggles with dynamics, how causal networks change, how gravity works. These are active research areas, not solved problems. Others question whether discrete events are truly fundamental. Maybe apparent discreteness emerges from something deeper. String theories vibrating strings, loop quantum gravity's spin networks. Causal sets might be effective description at certain scales, not final theory. Proponents respond that causal sets provide simplest explanation for spacetime's quantum nature. Discreteness is empirically motivated. Planck scale suggests fundamental graininess. Making this graininess causal rather than geometric elegantly avoids quantum gravity's technical problems. Philosophically, causal set theory makes time less mysterious. Time isn't flowing substance or geometric dimension, it's pattern in how events causally relate. This grounds time in something concrete causation rather than abstract flow or geometric dimension. It also preserves both determinism and emergence. Causal structure determines which events are possible given past events. That's determinism. But time emerges from this structure rather than being fundamental. That's emergence. Both coexist naturally in causal set framework. For consciousness, causal sets suggest temporal experience might arise from detecting causal relationships. Your brain processes causal information, what caused what, which signals preceded which. Temporal experience might be what causal information processing feels like from inside. This doesn't solve hard problem of consciousness, but suggests where to look. Investigate how brains represent causal relationships, how causal information integrates into unified experience. Temporal phenomenology might supervene on causal phenomenology. Causal set theory remains speculative, not yet empirically confirmed, not yet technically complete, but it offers compelling vision. Space-time as emergent from causal networks, time as relational and discrete, quantum gravity as fundamentally discrete causal rather than continuous geometric. If true, it means time's nature is profoundly relational, existing only in patterns of which events influence which others, with no background flow, no absolute duration, just causal structure from which temporal order emerges. Time doesn't carry events, events' causal relationships are time, and that might be as close to time's true nature as physics can currently reach. What if time requires awareness? What if experiential now is fundamental, with physics describing its structure rather than explaining it away? This consciousness-based approach inverts usual order. Instead of explaining consciousness from physics, explain time from consciousness. Let's explore this radical but persistent idea. Standard approach. Physics is fundamental. Consciousness emerges from physical processes. Temporal experience is how physical time feels to conscious systems. Time exists independently. Consciousness observes it. This is materialism's default position, most scientists' working assumption, but consciousness-based theories reverse this. Perhaps conscious experience is fundamental. Time emerges wherever consciousness exists, and physics describes structures within conscious experience rather than objective reality independent of consciousness. Time doesn't exist without awareness. Awareness creates temporal flow. This isn't mere idealism. Some physicists take it seriously based on quantum mechanics measurement problem. Observation seems necessary for wave function collapse, for quantum possibilities becoming definite actualities. If observation is necessary for physical events, and observation requires consciousness, perhaps consciousness is necessary for physics itself. Roger Penrose's quantum consciousness theory suggests microtubules in neurons undergo quantum processes that consciousness accesses. Gravity causes wave function collapse at certain scales, objective reduction, and consciousness connects to this process, making awareness fundamental rather than emergent. Time's flow might depend on this consciousness-gravity interaction. If consciousness causes collapse, it might cause temporal flow too. Before conscious observation, quantum superposition of multiple temporal states. During observation, collapse into definite now. Consciousness creates temporal sequence by continuously collapsing temporal superposition, generating flow from fundamental timelessness. This explains why temporal experience feels so immediate, so undeniable. It's not consciousness observing time, it's consciousness creating time. The flow you experience isn't representation of external temporal reality, it's the temporal reality itself, generated by your awareness continuously manifesting present moments from timeless quantum possibilities. Critics argue this is unfalsifiable, untestable, unscientific. How could we prove consciousness creates time versus observes time? Both theories fit all current evidence. Consciousness-based time is philosophically possible, but empirically unmotivated. Interesting idea without supporting evidence. Proponents respond that consciousness itself is direct evidence. Your immediate experience of temporal flow is as certain as anything could be, more certain than any physics theory. If physics contradicts this certainty by being timeless, perhaps physics is incomplete rather than consciousness being illusory. Moreover, quantum mechanics suggests observer dependence at fundamental level. Reality might genuinely depend on observation, not just our knowledge of reality, but reality itself. If observation matters fundamentally, and consciousness enables observation, consciousness matters fundamentally too. This doesn't mean consciousness is all that exists solipsism, or that individual minds create reality subjective idealism. It means consciousness might be fundamental aspect of reality, alongside but not reducible to physical properties, with time emerging from consciousness-reality interaction. Tononi's integrated information theory, IIT offers scientific approach. Consciousness is integrated information, fear the degree to which systems' parts causally affect each other in irreducible ways. Perhaps time emerges wherever fear's high, wherever information integrates significantly. No integration, no time. This predicts rocks have minimal time experience low Phi, insects have weak time experience moderate Phi, humans have strong time experience high Phi. Future AIs might have different time experience depending on integration architecture. Time becomes spectrum, not binary, varying with consciousness complexity. Philosophically, consciousness-based time resonates with phenomenology, the study of conscious experiences structures. Phenomenologists argue lived experience reveals time's nature directly, past retained in memory, future anticipated, present emerging between retention and protension. This experiential structure might be fundamental, with physics describing its objective correlates. Eastern philosophies also emphasize consciousness's role in temporality. Buddhist meditation traditions report dissolving time experience at deep concentration levels, suggesting time depends on certain mental constructions. Hindu Vedanta treats time as Maya, appearance within consciousness, not independent reality. Western philosophy historically separated sharply objective time physics versus subjective time experience. But perhaps this separation is false. Perhaps time is neither purely objective nor purely subjective, but intersubjective, emerging from consciousness-reality interaction, real but dependent, objective but consciousness involving. This doesn't solve all problems. How does individual consciousness create time that multiple observers share? Does time exist where no consciousness exists, in deep space, before life emerged? These questions remain difficult for consciousness-based theories, but it offers alternative to physicalist reductionism. Maybe consciousness isn't explained by physics, maybe time is explained by consciousness. Maybe awareness and temporality co-constitute reality, neither reducible to the other, both fundamental aspects of existence's nature, and perhaps that's closer to truth than either pure physics or pure phenomenology alone could reach. We've explored timeless physics, emergent chronology, eternal block universes, consciousness-based time. We've examined quantum mechanics, relativity, thermodynamics, philosophy, experience, and after all this, all the equations and thought experiments and frameworks, the question remains open, perhaps unanswerable. What is time? Does it flow or simply exist? Is it fundamental or emergent? Does the universe evolve or just is? These aren't merely unresolved questions. They might be unresolvable questions, at least with current understanding, and perhaps that's okay. Science describes relationships beautifully, how things correlate, how changes connect, how causes relate to effects, but it doesn't settle what's ultimately real. Mathematics maps territory without being territory. The Wheeler-DeWitt equation describes quantum gravity timelessly, but whether that description captures time's essence or just effective behavior remains mysterious. Both mathematical timelessness and experiential flow seem undeniably true from their respective perspectives. Physics says nothing changes, all moments eternal, complete, static. Experience says everything changes, moments passing, flowing, evolving. How can both be true? Perhaps through perspective shift, one view from outside time, one from within time. Like wave-particle duality in quantum mechanics, light is both wave and particle, not sometimes one and sometimes the other, but genuinely, fundamentally both. Which aspect manifests depends on how you observe it, but both are equally real. Perhaps time is similar, both flowing and static, both emergent and real, both temporal and timeless depending on perspective. We might need complementarity for time, accepting that complete description requires multiple incompatible perspectives, none sufficient alone. Physical description captures timeless mathematical structure. Experiential description captures temporal phenomenological flow. Neither is more fundamental. Both are necessary. This isn't satisfying if you want single unified answer. It's frustrating if you believe reality must be purely one way, unambiguously describable from neutral perspective. But reality might be richer than our demand for simplicity, more complex than our preference for single truths. Quantum mechanics taught us this lesson. Stop asking which slit the particle really went through, because the question presupposes classical categories that quantum reality doesn't respect. Similarly, perhaps stop asking whether time really flows, because the question presupposes temporal categories that deep reality doesn't respect. That you do experience flow, undeniably, continuously, unavoidably. This isn't invalidated by physics' timelessness. It's what it's like to be conscious structure embedded in space-time, processing information, integrating sensory signals, creating memories. The experience is real, even if interpretation is open. Maybe that's the deepest truth. Experience is certain. Ontology is questionable. You experience duration. That's indubitable. Whether duration is fundamental or emergent, whether time is real or constructed, whether universe flows or simply is, these are interpretive questions beyond direct experience. Science can't currently settle these questions definitively. Perhaps future theories will. Quantum gravity's completion, consciousness science's maturation might reveal answers. Or perhaps the questions will remain perpetually open, forever interpretable multiple ways, never resolvable to single correct answer. And there's something beautiful about that. Not knowing time's ultimate nature doesn't prevent living meaningfully, choosing freely, creating beauty, connecting deeply. The mystery doesn't diminish experience, it enriches it. You live in a universe profound enough to contain both timeless mathematics and flowing experience, both eternal structure and temporal change. Both descriptions are true from their perspectives. Neither reduces to the other, and the universe is vast enough, subtle enough, mysterious enough to contain both simultaneously, without contradiction. That might not be the answer you wanted, but perhaps it's answer reality offers. Not single truth, but multiple complementary truths, together capturing something too rich for either alone to contain. Not knowing time's fundamental nature isn't failure. It isn't gap in understanding awaiting clever physicists to resolve. It might be invitation to wonder, to remain curious, to hold multiple possibilities simultaneously without demanding premature closure. You live in a universe profound enough to contain both equations and experience, both timeless mathematical structures and felt temporal moments. This isn't contradiction needing resolution, it's richness worth contemplating. The tension between physics and phenomenology reveals something about reality's complexity, not confusion in our thinking. Consider what certainty would mean. Suppose physics proved definitively time is illusion. Nothing flows, everything exists eternally static. Would this change your experience? You'd still feel duration, still experience moments passing, still live temporally. The proof wouldn't alter the phenomenology. Or suppose philosophy proved conclusively, time is fundamental, flow is real, physics is approximation. Would this change the equations? Wheeler-DeWitt would still work, relativity would still predict correctly, quantum mechanics would still describe observations accurately. The proof wouldn't alter the mathematics. Both descriptions are useful at their domains. Physics needs timeless frameworks for quantum gravity. Life needs temporal experience for navigation. Both are real in their contexts. Demanding one be more fundamental than the other might be demanding false choice. Perhaps not knowing is appropriate response to something genuinely mysterious. Not mystery as temporary ignorance awaiting solution, but mystery as intrinsic feature of reality, aspects that resist complete explanation, that remain perpetually open to multiple interpretations, that are richer than any single description captures. The space between knowledge and mystery is where humans have always dwelt. We know enough to navigate reality, build technology, predict outcomes, but we don't know everything. Consciousness remains mysterious. Quantum mechanics is strange. Time's nature is open. This partial knowledge surrounded by mystery is human condition, and it's not uncomfortable if you embrace it. Certainty can be rigid, confining, limiting. Uncertainty opens possibilities. Not knowing time's ultimate nature leaves room for multiple perspectives, for scientific and experiential truths to coexist, for continuing exploration without presuming we've reached final answers. Wisdom traditions often emphasize not knowing as virtue. Socrates claimed to know only that he knew nothing. Zen Buddhism values beginner's mind, approaching reality without fixed conceptual frameworks. These aren't anti-intellectual positions, but recognitions that reality exceeds our categories, that genuine understanding includes knowing what we don't know. In contemplating time, not knowing creates humility. You can't claim absolute authority about time's nature when physics' deepest theories and immediate experience pull opposite directions. Both have legitimacy, neither has monopoly on truth. This humility opens dialogue between perspectives rather than declaring victor. It also creates peace. If you're not defending particular answer, not invested in specific interpretation, you can hold paradox lightly. Time flows and doesn't flow. Both are true from different perspectives. The contradiction doesn't need resolution. It needs acceptance, appreciation, gentle contemplation. You're not failing by not knowing. You're participating in something larger, the ongoing human project of understanding reality, which has never been complete, will probably never be complete, but is valuable precisely for being open-ended. Each generation builds on previous understanding while discovering new mysteries. Time's mystery might be permanent feature, not temporary gap. If so, accepting this is sophistication, not surrender. It's recognizing that some questions might not have single correct answers, that reality might be richer than our explanatory frameworks, that wonder and uncertainty can coexist with knowledge and understanding. The gift of uncertainty is this: you get to explore rather than merely know, wonder rather than merely comprehend, hold multiple truths rather than grasp single truth. And in that exploration, that wondering, that multiplicity, perhaps you touch something truer than any definitive answer could provide, the inexhaustible mystery that reality fundamentally is. If the block universe is real, this moment reading these words exists permanently. You're always here, always thinking these thoughts, always experiencing this specific now. Your consciousness at this moment is eternal feature of space-time structure, as real and present as any moment could be. This feels strange. You experience yourself as temporary. This moment will pass, become memory, fade into past. But if eternalism is true, this moment never passes. It exists forever at its temporal coordinate, with you experiencing it eternally. You right now is permanent aspect of reality's four-dimensional geometry. Every moment of your life has this status: your first memory, your worst mistake, your greatest joy, all eternally present at their respective coordinates. Nothing is lost, nothing becomes non-existent. The moments don't fade, you move past them temporarily, but they remain behind you, eternally real. This transforms how you might think about your life. You're not brief spark here for moment, then gone. Your eternal structure extending through space-time, from birth to death. Every experience you've had is permanent. Every connection you've made is forever part of reality's fabric. Every moment matters permanently rather than temporarily. Your life isn't brief spark but extended four-dimensional world line, complex and curved, interacting with other world lines, existing completely from beginning to end. All of it, every thought, every choice, every breath, is permanently real. You are eternal in the only way that matters. Your existence is unchangeable fact about space-time structure. This doesn't make death less significant. Your world line has terminus, boundary, endpoint. But bounded existence isn't diminished existence. A finite line is no less real than infinite line, just different shape. Your life's boundedness makes it definite, complete, whole, rather than incomplete or unfinished. Even in emergent time interpretations, this moment creates permanent records. Your current brain state influences future states, spreads correlations through environment, affects trajectory of others' world lines. The influence is irreversible. Information spreads but doesn't unspread. This moment ripples forward eternally through correlation networks. So whether time flows or doesn't flow, whether moments are eternal coordinates or emergent records, this moment matters permanently. What you think now, feel now, choose now, all have eternal consequences. Not merely lasting consequences, but eternal consequences, spreading through space-time or correlation networks forever. This gives weight to present moment that's easy to miss when thinking of time as flowing river, where present is temporary, insignificant, soon to be past. But if present is eternal, or if present creates eternal correlations, then now matters absolutely, finally, unchangeably. Perhaps this is both liberating and terrifying. Liberating, you're not temporary, not erasable, not insignificant. You're permanent feature of existence, forever woven into reality's structure. Terrifying, your mistakes are permanent too, your failures eternal, your worst moments unchangeably part of what is. But unchangeable doesn't mean unforgiven or unredeemed. Permanent moments exist in context before and after, cause and effect, growth and learning surrounding them. Your mistakes are permanent, yes, but so is your learning from them, your becoming better, your redemption. All permanent, all eternal, all part of your complete four-dimensional story. And if moments are eternal, then joy is eternal too. The love you feel right now exists forever at this coordinate. The beauty you witness, the peace you experience, the wonder you feel, all permanently real, all eternally part of what is. Nothing beautiful is lost, nothing meaningful is erased. You are always here, in every moment you've lived, experiencing each eternally, multiple yous distributed across time, each real, each present at their coordinate, and somehow, mysteriously, all connected into single continuous you, single world line, single story, single eternal structure that is your life. This is what eternalism offers. If it's true, permanent significance, eternal presence, unchangeable reality. Your life isn't fleeting, it's forever. Every moment you live is always happening, eternally real, permanently part of the universe's structure. And perhaps that's enough. Perhaps that's everything meaning could be. Perhaps you came here seeking answers, or perhaps you came seeking peace. Either way, here at the end, there's something to say about where we've arrived together. The universe unfolds, or simply is, either way containing you within something vaster than comprehension. Whether time flows like a river carrying you forward, or whether you exist eternally at your coordinate in four-dimensional space-time, or whether both descriptions capture different truths about the same reality, in all cases, you're here, experiencing this moment in ways that feel undeniably real. You've encountered ideas tonight that might seem strange, even disturbing. Physics suggesting time isn't fundamental, consciousness perhaps creating temporal flow from timeless structure. The possibility that all moments exist eternally, that nothing truly changes, that your entire life is static four-dimensional shape extended through space-time. These ideas can't be fully grasped in single contemplation. They're meant to be visited repeatedly, turned over slowly in quiet moments, allowed to settle gradually into understanding. not forced into premature certainty but held gently, examined from multiple angles, appreciated for their strangeness and depth. And you don't need to resolve them. The questions can remain questions. The mysteries can remain mysteries. You can live meaningfully, choose freely, love deeply without knowing whether time fundamentally flows or emerges or exists eternally. The uncertainty doesn't diminish life, it enriches it with wonder. Time flows or doesn't flow. You experience its passage either way. Moments are eternal or emergent. They feel real regardless. Your choices shape reality, whether they create open futures or enact eternal structures. The metaphysics matter for understanding, but life matters for living, and living happens beautifully in either framework. So rest in the question. Let uncertainty be gentle companion rather than frustrating obstacle. The universe is vast enough to contain both flowing time and timeless structure, both equations and experience, both what physics describes and what you feel. All of it real, all of it true from their perspectives, none requiring you to choose between them definitively. For now, in this moment, real or eternal, there is simply this: your breath moving gently in and out, your thoughts drifting wherever they drift, your body resting wherever you are. These are certain, these are immediate, these are undeniably here, regardless of time's ultimate nature. The infinite patience of mysteries that need no resolution tonight awaits your return whenever you wish to contemplate again. The questions will remain, as questions do, inviting exploration without demanding answers. And you can rest in that invitation, in that openness, in that gentle acceptance that some things are too rich, too deep, too mysterious for final comprehension. Time passes or doesn't pass. The universe evolves or simply is, and you're here, breathing, experiencing, existing within it all, permanent or temporary, eternal or emergent, flowing or static, but always, undeniably here. That's enough, that's everything. That's the one thing no theory can question, no equation can dissolve, no mystery can obscure. You are here, now. However that now exists, whatever that here means, it's real, and in this moment's reality, whether eternal or passing, you can rest, simply rest. Let the questions be questions, let the mystery be mysterious, let time be whatever it is, and let yourself be here, gently, peacefully, completely, now and forever, in whatever way forever means.